Good morning, everybody. A warm welcome to all of you. I'm Antara Kundu, Project Executive of South Asian Institute of Advanced Research and Development. Thank you for presiding over the third and last day of International River Congress. Hope you have enjoyed our last 2 days session and will enjoy our today's session as well. So after having a successful second day session, we are heading towards the end today, but today our first session will be a technical session. And for that technical session, our chairperson will be Dr. Piyush Rautela, Executive Director, Uttarakhand State Disaster Management Authority, Government of Uttarakhand. I would like to request sir to come up on the stage and take his seat. Dr. Piyush Rautela. I request Dr. Bishwajit Roy Chaudhuri to felicitate Dr. Piyush Rautela. And I request the team to bring the bouquet on stage. So today, for the technical session, we have special lectures by the international delegates, and it will be happening virtually. So for the first lecture, we have Professor Shuchita Sharmin, Professor, University of Dhaka, Bangladesh. She will be speaking on assets and vulnerabilities of the Choi dwellers, and I would like to request our team to connect her so that she can give her presentation.
Yes, thank you very much. Can you hear me? Okay. Okay, wonderful. Thank you very much. At first, I'd like to. Okay. It's like I'm not always very formal, but I'm on my way. So I'm inside the car. I hope you understand the traffic jam and all here in Bangladesh. Probably some of you know about it. And actually, I'd like to first congratulate Saiard for organizing such a wonderful, what should I say, Congress, because it is what we actually need at the regional level. And Saiard is the right platform to initiate such Congress. And I also would like to congratulate the chairperson of Saiard for his, I can very much understand the pressure he has taken with all the force he has got in his office. And I have seen the people who are joining this Congress, and it shows that people are really being very much enthusiastic and joining and thinking about the problems in a very much regional level, at a very much regional level, and also in a holistic manner. And with thanking both Saiard and the chairperson, Dr. Bishwajit Roy Chaudhary, I'd like to start my presentation today. Actually, it is about assets and vulnerabilities of the shoreline people. And especially in this South Asian context, in this subcontinent, we know that we have many rivers, and at the like in different parts in the active river basins, we have the shorelands. Because of the erosion, river builds its own land in course of time. While river is eroding in one part, the chores are growing in the river bed in the other part. So this is how shorelands are considered. And in my study, I considered chores. There are two types of chores that I considered. One are the those in a river chore, and there are also the river estuarine chore areas, shorelands, where I wanted to see the assets and vulnerabilities of people for their survival, for their livelihoods, for their lives, etc. So actually, it is a part of a very big study that I have conducted, and the data had been collected in just before the SDG era, So it was during the MDG era, before 2015. However, the issues are always relevant, and in that way, I considered this to be very important. Now comes the issues of what I was looking into. And actually, today my presentation will be talking about a little about the methodology and also about my findings. I won't be elaborating it here. Maybe in the paper that I'll be submitting finally, will give you the whole essence of what it is. And because I also understand that the time limit is also here. So with so many participants, I know I don't want to actually elaborate my presentation much, but of course we need to understand a few things, like understanding the context. So when I was talking about the river chords, I was referring to Jamuna river chords, and when I was talking about the river estuarine chords, I was talking about those chords who are in the river, those chords that are in the river estuary, and in the estuary of Bay of Bengal. So you understand the context now, and in that context, people also are very different. Their cultures are also very different. And when I was thinking about the lens through which I'll be looking into the matters, I considered sustainable livelihoods framework as the framework for analyzing the issues of lives and livelihoods. And sorry. The thing is, uh, uh, now the question comes as to, with that sustainable livelihoods framework, what are the issues that I considered? I considered the asset pentagon, where we have those human, social, natural, physical, financial assets, and as well we have the context, the geographic context, the policy context, and the cultural practices and norms of the people. So all these issues I considered, and you can of course understand when I'm talking about the chore areas, I'm also talking about the disasters that the people in these chore areas face. So it is through this lens I wanted to look into the matter, and the special focus was looking into how these what assets does these people have, and what vulnerabilities do they have, and actually when there are NGO interventions, or when there are government interventions, private interventions, how these assets and vulnerabilities are working or not working, and what are the obstacles that are hindering the progress of the people in the shorelands, among the shore dwellers. So with these uh, objectives, I started, and now I go to the methodology part, where I focused, I used a mixed method, because actually I needed generic data, generic in terms of asset related data from respondents at the household level. As well, I needed in-depth data, where what I could collect from the FGTs and KIIs. I collected data from two chore villages of Jamuna River, and also two chore villages of Tetulia River, that is the estuarine river. Those are the estuarine river chores. And actually, when I talk about all these, when I'm talking about sustainable livelihoods framework, and now if I look into what I found, I tried to look into the matters in terms of their livelihoods consequences, and also in terms of sustainability of development achievements. You all know that when I'm talking about sustainable livelihoods, people need to have livelihoods options and alternative livelihoods options, as well as they need to have the assets that help them go forward with their livelihoods. Now it is about, if I now go back to the findings, specific findings, and it is, just give me a second, if you please. When I start with human capital and about the major findings from human capital aspects that I found, and of course I have done the analysis comparing. There are correlations, and even it shows that in terms of human capitals, these two chore areas are not always the same or similar because of the cultural practices that are very much unique at times. And even when we are talking about human capital, we see that there are differences because of the context, the geographic context, and the cultural practices. So when it is about the human capital, of course, is considered as asset. And of course, human capital is also a vulnerability for them when thinking of adjusting and considering about livelihoods. So as asset, what we saw is that male children are considered very much important and as human capital in the southern estuaranchal because they engage into fishing and fishing related activities from a very tender age, around 14, 15 years of their age. Of course, their health related issues are considered here. And interestingly, as we can see, it is about health related issues like in the estuarine area, they get good quality fish, and they with that facility, they actually are able to have good health and nutrition, and they work hard in the fishing context as fishing in their livelihoods. And on the other hand, it is again very much hazardous because as we know about ILO 182, that article in their issue about child labor related considerations, ILO has said that children should not be engaging in hazardous physical labor. And though hazardous physical labor is fishing, people are not considering it in that way, in a manner that it is also causing vulnerability to the children who are engaging in fishing at a very tender age. So this is how we started looking into so many other things, and it is just one part of my finding which shows about human capital. And again, there are many other dimensions, like in the northern part of Bangladesh, what we see is we have uh, domestic violence. So what we do, we we found that it is a culture, and because of that, women are becoming victims of violence as well. They are becoming mother regularly, like they have many children, and the poverty rate is very high. So there the issue is about empowerment of women. In this way, I just don't want to elaborate much on all the findings. What I would like to conclude with is the reality that when we have to look into such matters, like when we have to look into the development in a holistic manner, as we see that we always want development in many ways, like in a holistic manner. We cannot leave anyone behind, as the slogan of SDG is, leave no one behind. We have to consider all different aspects of our assets and vulnerabilities that are hindering our development. And here the concluding findings that I have highlighted in this study are that the household level experience, expertise, assets, and vulnerabilities interact with the community level cultural practice. And of course, we may introduce many different types of interventions for the development, for the holistic development, but people have to own those. And then the second specific focus is on long-term interventions by different agencies all together on a specific sector, because when the NGOs are working with short-term interventions, those are not bringing about the desired changes that we want in the cultural sector at the asset level. And again, the third focus is on the missed out concerns. When it is a disaster, we may not have sufficient food for survival. We may have, like the people usually cope in a manner that they eat once a day and then cope for months, and finally they go for, if possible, they find any other livelihood options, they up that. But the physical consequences of having one meal a day continues, and it's not possible to repair that. And at the same time, as I've said, the physical labor that the children give in fishing related livelihoods related activities, their physical hazards are not repairable, irreparable. So this is how the third focus of my findings is the missed out concerns in terms of asset base and those that are leading to vulnerabilities. And for ensuring sustainable development and sustainable livelihoods, these missing concerns should be considered. And of course, specific focus should be given into the cultural and geographical context in which people are becoming vulnerable to different disasters and due to their lack of assets and the vulnerable cultural practices and norms. And this is all from my side. And thank you for very much for your patient hearing.
Thank you so much, Professor Shujita Shamin, for your presentation, for joining us today, and for giving the presentation. Thank you, ma'am. So,
Thank you very much too.
yes, ma'am. Thank you. So, up next, we have a presentation by Dr. Surojit Ghosh, Regional Researcher, International Water Management Institute, Colombo, Sri Lanka, and he'll be speaking on use of disruptive technologies for flood and drought monitoring. I'd like to request sir to give his presentation, and I request our team to connect him. Yes, Dr. Ghosh, can you hear me?
Yes, good morning to all. I can hear you.
Good morning, sir.
Hope you can see my screen also, right?
Yes, sir.
My screen is visible, right? Thanks.
Yes, sir.
So, good morning to all of you. Myself, Shurajit Ghosh. I'm working for International Water Management Institute, based in Colombo, Sri Lanka. And our mission vision is for water secured world. Today we'll talk on the use of disruptive technologies for flood and drought monitoring, assessment, and how we can use those kind of technologies. Specifically, we'll discuss on, I can say, Earth observation data for tourist station. And I'm specifically working on the South Asia region and Africa region as a regional researcher. So let's start today's discussion. The key issue for any flood disaster and all this last few years, we have lots of floods events are there, and it is monotonous increasing trend, we can see. And this is not for only flood, for the other hazard also. And this is a global scenario, this is regional scenario, but when you talk about a specific area, that is again another complexity. Complexity in terms of, you see, this in area like South Asia or Africa, we have many smallholders farms, and impact of flooding or drought on the farm actually different in different way based on their agricultural practices and everything. So what we'll try to see in today's presentation, that how we can assess those risks, how those technologies can be helpful to reduce their risk, and what's the future of this kind of technologies. And who are very familiar with this Earth observation data, they know that there are different kind of data sets are available, which has been captured from different platform. And nowadays we have different spatial resolution as well as spectral resolution data sets are available, and almost around 40 years of data sets are there. And when we talk about this kind of data set, we need to have a specific software or specific platform to access all these data sets, which is not possible by our conventional or traditional system. So so we are looking for a new solution, a new platform, which is already developed in many cases, but it is an emerging field in any way. And the solution is coming from cloud and the machine learning platform, I can say. Why it is so much promising? Because it is very easy to use. You can use from anywhere, I can say everywhere, with any devices, and it has a higher security, and it has really reliable information with near real-time dissemination facilities. And it is also actually discussed, and we assume that by 2025 we'll get much more public cloud system, and so it will be our daily uses, the this specifically public cloud and all. So what are the public clouds? This Amazon Web Service is one of that example. Google Cloud is another one example, I can say, and another Microsoft Azure. All these are those kind of cloud system. Based on that, different geospatial application has been developed. One of them is Google Earth Engine. It is freely available for research. So nowadays it is very popular. And if we see one of such criteria or architecture, I can say, that you can integrate different geospatial data. You can integrate your own data sets, like you have, as Dr. Sharmin told, that you have some socio-economical data sets with the geo tagging. You can also integrate all those things. You can run your machine learning algorithms and get the data from village level to the continental scale, even global scale data. So that's why it is very easy to use. High performance systems are available, and it is really a very low weight platform, from where you don't need much high-end computation system at your end. You just need some good internet. You need some login ID. That's all. You can do everything on cloud. So if I can show a few examples. This is a very interesting example, I can say. This Burevi is one of the cyclone hit at northern part of Sri Lanka. And this is a SAR data, synthetic aperture data. It's a very high quality data where you can get flood inundation even in a cloud situation. And when you compare the real time our precipitation or rainfall data, what we can see within if actually top figure, you can see it is on 12:30, and the below one is 18, means 6 p.m. So within almost 5 or 5.5 hours, the country situation in terms of affected household has increased, and badly affected this particular northern part of the country, I can say. So this kind of information within a day we can disseminate, which was not possible earlier. With this kind of technology, cloud system, and the new algorithm, that helps to disseminate the information almost near real time. And the integration of different data sets, that is another part, I can say. Similar way, this application is not only for Sri Lanka. You can take this application and you can use the platform for other purpose like drought monitoring. We have done this work with World Bank, that integrated drought monitoring system, where we have used different sets of data sets, and this is online available, as well as it's a real time, I can say, and where you can use this rainfall data, your vegetation condition, your soil moisture conditions, and you can create an integrated drought risk. We have in EME, we have a PSI integrated drought severity index, which is very popular nowadays, and we have tested in different regions from South Asia to Africa. Like this is one example from Senegal. I can show another example where you can see that this is for Afghanistan drought early warning system, and here you can very easily access 20 years of data from vegetation index. To vegetation index is nothing but to understand the vegetation condition of the area, as well as soil moisture, rainfall condition, everything. So this is the power of cloud computing. If we have some time, I can show later that how the system is working. These systems are available in and running in web browser already, and we can also get the statistics also. It is not the only map, so you can also get the statistics. So similar way, from flood to drought, drought to flood, we can play based on the available data sets, long-term data sets. We can see this is almost South Asia level, what is the flooding condition of last few years, and you can make it such a way that different frequency you can catch here, and very easily you can see our region or northern part of Bangladesh, let's say uh, Kurigram and all this area, as well as the area from Bihar, Muzaffarpur, as well as the Pakistan. These areas are really vulnerable due to the flood. So this kind of work we can do very easily using the cloud platform, Earth observation data sets, and machine learning techniques. Not only that, what we can do, we can use all this data, we can use our hierarchical modeling, we can put all this in the cloud like AWS, and within few minutes we can generate the discharge, as well as for a large basin. And this is the kind of capability with this kind of, earlier it was actually maybe 1 or 2 days it may take. So that's the way we are working on. But this, yes, I can understand, let's say people can understand, you can map flooding, or you can map drought, you can run hierarchical modeling on cloud, that's all. But what we can do all this, so what we can do using all this technology, we can assess the crop damage. Let's say you have some flooding happened in somewhere. Let's say this is one example from Bihar. So from the Sentinel data, Sentinel-1 is a very high resolution data, almost 10 meter by 10 meter square pixel. And you can even map the flooding in the at the village level. And also with these data sets and the digital elevation model, you can measure the flood depth also. And if you know this is the flood situation, the duration and the depth, and then you can assess the damage based on this information. So this is one kind of information where you can assess the damage and inform to the government, and they can take necessary action. Even this kind of scenario can be held during in-season flooding. In-season flooding is what? Let's say in a particular season, you sometimes you have the early flooding, sometimes you have mid flooding, means when the crop is grown and almost go to mature stage, that time you may have flood. So even sometimes when after showing you have a major flood, what we have seen in 2019 or 2020 in Bihar. So within few weeks, you can get all this information and take the necessary action. So that's the another example. So not only damage, I can say if you know the flooding condition and all these, and if you know what is the crop stage, then you can very easily assess the damage. And if you know the cost of production or input cost, and if you have this particular damage curve with you, it is available in from very many secondary data sources. You can very easily assess the crop loss during that particular flood event. So the right side map is a village level crop loss assessment. So this particular village has high loss, and we can convert it to some dollar or rupees. And these villages are low loss areas. So based on this information, we can take the action. We can support the farmer and de-risk the farmers and the farmland. So when it talks about the de-risk, we need some kind of insurance then. So the main motto is to use all this data and insure the farmers and the farmland. So we have some example. We have worked in different places for the de-risking part, and the index-based flood insurance. We have worked in last 5 to 6 years, I can say, and there is a different way of data integration and the dissemination processes are involved. So this is one of the example from Bihar, where flood depth and duration data has been used with satellite data as well as the flood modeling. And based on that, flood insurance payout has been happened in last 4 years from 2017 to 2020. So these are the few picture from that payout ceremony. Similar like Bihar, we have worked in Bangladesh, the Chod area, what Dr. Sarvani told that in the northern part or the middle part, we have Fulchedi, Sugata, or Jatrapur or Chilmari. These areas are Chod areas and very much flood prone. So we have some product where approx 6,000 Bangladesh Taka payout has been done for every or individual farmers in 2019 flood near Gaibandha as well as the Kurigram areas. So this kind of application we can use by use of this kind of satellite data and the techniques. Also, we can do monitor with a frequently, let's say every 8 days, we can monitor the flooding situation, and based on we can take the action. And as a recognition of our this work, in 2020 we got this innovation award. It is the first time the one of the CG Center got this innovation award from GEU. I can share the video link and we can go through this. So this is from our IBFA product where we have used this kind of disruptive technologies to understand the flooding situation and help to the farmer for getting payout. And similar way for drought condition, we are working on this bundling insurance. Is called a BIXA, Bundled Solution to Manage Agricultural Risk, where we have seed inputs. I mean to say, we provide the seed, we provide the weather forecast and the agri advisory, and as well as where they can procure the grain, and we are working on the credit link. So all this together we call this bundle solution, and this is one of the example of bundle solution in Bihar. You can see the IMI bags where we provide the seeds and everything, and based on that, this is basically drought tolerant seeds on that particular area, and we can get the good production, and it's a very good solution or de-risking factors to the farmers. So I'm just almost come to the end of my presentation. we have everything. Let's say we have flood mapping, drought mapping, we have insurance. From there, we know how to manage the risk. Now, these are all part, but we need to think about the integrated water resource management, and we need to understand how the river system actually work. It is not that only river flowing longitudinally, but it has a different way of interaction. It is laterally interacted. It has an interaction vertically. Also, over the time, it changes. So we need to understand all these dynamics. And recently we have published one policy paper. If anyone want to understand those things, they can read this particular paper. And once we have understand these things, and that can be supported by the satellite observation like this, it has a 40 years of data, and we can see very easily what areas are with too much flood prone and where we need those kind of actions or precautions or mitigation or the resilience, everything can be associated with this. So we have seen that the chord areas of Bangladesh is really flat prone, Howard area as well as the part of Assam and part of Bihar as well as the deltaic region. And this more blue color means basically it is a more flat prone, and red color basically is less flat prone. Flat prone. And this is not a single state data, 40 years of data, which is not possible with our traditional system, but with the help of this kind of cloud computing and machine learning, we can reach this part. And this we have machine learning, we have cloud platform, we can do wonder from early warning to assessment, mapping, monitoring. You can scale your product. These are really reliable product where less human interference is there, less processing time, and you can reproduce. But again, these are the technological part, but we need to understand the nature. We need to understand the human nature synergy. So with that understanding, if we use the technology, that could be the best solution, that could be the best resilience, I can say. With this, I would like to take questions or queries if there is any. Thanks to the organizers, thanks to the chair, and whoever present here. Thanks to all. That's all from my end. Thank you.
Thank you so much, sir. If any of you have any queries, you can ask that. Yes, sir. Can you just hand over the microphone to the... I'd like to request Dr. Shurajit Ghosh to wait for some time because we have a question.
Thank you. Just one thing that is this planning management or this structure or this design applicable in plateau region, where hard pan is there, and then it applicable, then how it applicable in that particular region, basically in Purulia or Bankura district where there is a large part of hard pans are there. So they are in flood management. So how in that area flood management is we can plan for that?
Extremely sorry. Actually, I could not hear you properly. There's a lots of howling is there. So if someone can
Sir,
help me to understand the
Yes, sir. Just a
query.
second, sir.
Otherwise, I can share my email ID. You can just let me know. Happy to. I'm happy to answer those. I can't hear properly actually.
No, sir. Just a second, sir.
Sir, can you hear me?
Yes, now it is better. It is better.
Okay, sir. Sir, actually, I am asking for the flood management in plateau area, basically where hard pan is there. Basically in Purulia in Bankura district, where there is a large part of lateritic soil and there is a huge possibility and huge occurrence of surface runoff. Flood management plan will be initiated in that particular area.
Okay, fine. That's the very specific, or I can say region specific issues that we need to handle. And if you talk about the technologies or the data availability, I can say you can use this kind of data and the platform for flash flood to the usual flood scenarios. And nowadays we have the data, at least I can say in the free domain, it is 10-meter resolution or 10-meter by 10-meter pixels are available. So you can very easily use those SAR as well as the top optical data to map and monitor as well as the damage assessment for that particular area. Even it is a plateau, that could not be any issue. But on the flood management, that is a different query or different questions that need some more information about the area as well as the policy for that particular district. Hope I can answer your query.
Yes, sir. He has got his answer. Thank you so much, sir.
Thank you. Thank you.
Thank
Thank
you
you
so
very
much
much.
for joining us, sir, and giving your presentation. Thank you, sir.
Thank you. Thank you.
Okay, so now we have a presentation on wastewater management and pollution avoidment, and this presentation will be given by Ionina Deherne from Australia. I'd like to request our team to connect her.
I'm trying to share my screen, but
Sure.
it's not working. Is that? Hmm. Okay. Hello everyone. It's an honor to speak to all of you here today. My name is Yanina, and I'm 18, and I'm very passionate about the environment. And today I'm going to talk to you all about river pollution and certain solutions. There are many different types of pollutants affecting the health of our rivers. And this leads to even greater problems because rivers, oceans, land, and air are all connected. As you probably know, a river is a large natural stream of flowing water. They are formed from melting glaciers, melting snow, a lake, or a spring. From its source, whatever formed it, the river flows downhill. Precipitation and groundwater add to the river's flow. It also is fed by other streams. Precipitation, groundwater, and feeding streams all carry pollution. The end of the river is called its mouth. Here the river empties into another body of water, a larger river, lake, or the ocean. How the river carves and shapes the landscape is called weathering or erosion. Eroded polluted soil enters the river. Downhill, the river begins to leave behind some of the rocks, sand, and other solid materials collected upstream, spreading the pollution. Some pollutants that might be found are litter, microplastics, pesticides, and sewage. In the ocean, water constantly evaporates, forming clouds. Clouds carry moisture over land and release as precipitation. This fresh water feeds rivers and smaller streams. If there is any pollution in this evaporating water, seawater, then this pollutes the air as well. This can cause acid rain. This whole process is called the water cycle. Since everything is connected, it's very important that we stop this pollution not only in the rivers, but also in the air and on the land. We should all care about how this cycle works and how everything is connected because we humans depend on it for our survival. In prehistoric times, people settled along river banks where they found fish for eating and water for drinking, cooking, and bathing. Later, people learned that the fertile soil along rivers is good for growing crops. Centuries later, rivers provided routes for trade, exploration, and settlement. Many cities of the world today are situated on or near rivers. For example, New York City, USA, Buenos Aires, Argentina, London, England, Cairo, Egypt, Kolkata, India, and Shanghai, China. Rivers also provide electricity to many towns and cities around the world. 19% of the world is powered by hydroelectricity, which is a renewable source because water can be replenished quicker than it is being used. Rivers also provide food and water, which we all need to survive. So let's protect our rivers together. What can we do to protect our rivers? First, our rivers need to be cleared from harmful pesticides. Especially farmers often claim that they need pesticides to protect their crops and to increase crop yields. However, scientists have proven that, in fact, in the long term, pesticides decrease crop yields. This is because pesticides go into the soil and kill beneficial organisms. This reduces biodiversity, leading to less fertile soil and therefore resulting in less plant growth. Moreover, science has proof that when we do not use pesticides, more water is retained in the soil. So this water is essential for plant growth. So we will in fact have better crops and more water and less water use, smaller water use. It will be smaller if we don't use pesticides. As the earth is warming and we see more droughts, it is even more important to reduce the use of pesticides. In addition, by using pesticides, we kill our own crop pollinators, like bees and butterflies. Moreover, about 200,000 people die from pesticides each year. Another thing all of us can do right now to protect trees is protect trees and at the same time plant more trees. I'm a part of a group now called Save the Manningham Trees in my community, and our mission is to protect as many trees in our community as possible by changing policies and by planting more trees. Trees provide shelter for animals. Trees provide shade, which helps maintain oxygen. Trees on riverbanks help reduce evaporation of the river water. Not only living trees are important, but also fallen trees. Fallen trees trap sediment and reduce the amount of runoff that enters the rivers, so trees reduce pollution of river water. Tree roots can stabilize river banks and reduce the rate of erosion. Leaves and wood that falls in rivers provide nutrients and food for important organisms. So trees are useful in cleaning rivers and other ecosystems and for stopping the spreading of pollution. Third, it is very important to stop the deforestation of mangroves for more houses, buildings, and parking lots, because mangroves are essential. For example, here in Australia, according to the Australian government and the Australian Institutes of Marine Science, 75% of the commercial caught fish and prawns in Queensland spend at least part of their life cycle in mangroves. If we eliminate them, many species lose their home. Not only commercially caught fish and prawns rely on mangroves, but also spiders, snakes, bats, and saltwater crocodiles. Mangroves filter out the salt so that other plants and trees can also use the water. We don't only need to stop the deforestation of mangroves, but also prevent oil spills. Oil suffocates the mangroves, disenabling them to get to the amount of oxygen they need. Today in Queensland, Australia, all mangrove forests, including all stumps, seeds, and leaves of the mangroves in Queensland, are protected under the Queensland Fisheries Act. And any activity involving mangroves requires a permit from the Queensland Department of Primary Industry. Another successful example of mangrove protection can be found in India. Mangroves are protected under many acts like the Environment Protection Act, Indian Forest Act, Wildlife Protection Act, and the Forest Conservation Act. India is also working with the UN to protect the mangroves. In the last 6 years, according to the 2019 State of Indian Forest Cover Report, mangrove forest cover in Maharashtra has increased by 72%. Still more can be done, and constant monitoring is a must. Another way we can all help is by testing the water quality on a regular basis. My friends and I got trained by Water Watch Melbourne, Australia. We helped test for the level of ammonium, a type of salt, phosphate, another type of salt, turbidity, the clarity of water, pH, the acidity of the water, electron conductivity, the potential of the river to conduct electricity, and macroinvertebrates. Some do well in poor water quality, while others do well in good water quality. Scientists use this data to analyze the state of pollution of the Yarra River and to find solutions to improve the quality of the water of this river. And lastly, cleaning up your rivers by organizing a cleanup or becoming zero waste is an easy way to help your rivers. It reduces the amount of litter and microplastics currently present in the water cycle and food chain. Still a lot more needs to be done in this area. I hope you enjoyed my presentation, and I hope you feel more encouraged to take more action to help our rivers. Thank you. If anyone has any questions as well?
Thank you so much, Ms. Yanina. Yes, we have a question. Can you just, you come to this place and ask that? Just a second, Yanina. Yes, sir, carry on.
Hello. Am I audible?
Yeah, I can hear you.
Okay. Actually, there is no question. I just want to congratulate you
Thank
that
you.
you have very nicely demonstrated the whole purpose of ecosystem management. That is the issue. We do mistake by segregating the environmental components, interactions, and dynamic aspects. Those you have clearly demonstrated, and this will be a lesson for us, all of us, particularly those who are thinking, I am air pollution specialist, I am water specialist, I am river specialist. No, we are to work together for the environment. Whatever is possible, that is important for us. Thank you very much to you.
Thank you.
Thank you so much, sir, and thank you so much, Yanina Dehanne. Thank you. Okay, so now we are going for paper presentation virtually. The first one is analyzing land use or land cover changes of Charkha Dadri city using Google Earth images by Asha Rao and S. Kumar Bansal. I request our team to connect them. Yes. I'll say, sir. I understand, sir. I'll say. Miss Asha Rao, can you hear me?
Yes, hello. Good morning, ma'am.
Yes, good afternoon, ma'am. I request you to complete your presentation briefly as we are running out of time, ma'am.
Okay, ma'am. I can say hi. Good morning, all of you. First of, thanks for Chairperson Dr. Piyush Rotela and Co-Chairperson Miss Visakha Jha. And thanks for inviting me here today. I am Asha, MPhil scholar of Geography Department of MD University, Rohtak, Haryana, under the supervision of S.K. Bansal sir. And my presentation topic is analyze land use land cover change of Charkhi Dadri city of Haryana using Google Earth image and GIS. So, a center point of urban geography study is urban and urban area. The idea of the city change according to country, time, people, organization, and circumstances. Land use covers classification and change reduction in different time frames. Information is required for policy making and administration purpose or development. And here is the my study area map. So, Charkhi Dadri district is one of the 22 district of Haryana. The government of Haryana officially notified Charkhi Dadri as 22nd district on 1st December 2016. Uh, uh, lo- lo- Latitude of Charkhi Dadri district is 28 minute and 59.21 north, and longitude is 76.26.53 east. So basically my study objective is land use land cover change in different time frames using remote sensing and GIS. So methodology are acquisition of the satellite image of the study area from Google Earth, those 2006, 2016 and 2021 for and taking coordinates and georeferencing of satellite image, extracting study area through extracting by clipping method. So the process of downloading of satellite image here, we can open Google Earth Pro, navigate and click and save our image. And georeferencing Google Earth image. Basically, georeferencing is the process of determining geographic coordinates, let alone from a textual described locality description, measurements of uncertainty associated in the form of radius form of the determined point or a polygon, and encompassing the maximum possibility
Hello,
extent of a
Miss Asha
locality
Rao.
description are usually included in the georeferencing process.
Ma'am, sorry to
So,
interrupt you. Can you just zoom your screen a little bit because we can't see the screen properly?
now, ma'am,
No, ma'am, it's not working.
am I audible, ma'am? Or
Yes, you are audible, but we can't see your screen properly.
I'm sharing my screen, but can I continue?
Shall I tell her to continue? Yeah, sure, ma'am. Okay, please continue.
Okay. Now, first of all, we take 2021 image from Google Earth. Then after that, we classify the image. First, first we classified image in water body, agriculture land, vegetation, unbuilt up land, settlement in different colors. Here we see that red color is settlement, yellow color is unbuilt up land, and green, light green is vegetation, and dark green is vegetation, and light green is agriculture land, and blue in water body. Dark. So after that, uh, as the same, we take three images as well, 2006, 2016, and classify all them. And after we here the map is settlement, we show the settlement in 2006, 2016, and 2021. So we can see that change in different years. After that, agriculture land change, water, and now water body for change. So the study provide needed supplement geospatial information about land use, land cover change of Charkhidadi city over the 15 years. Also, the significant change detection has observed during the study period. Agricultural area decrease, 40% settlement area in cities increase, road network have increased inside city and nearby area of the city. These changes allowed have implication from sustainable resources management and the livelihood of the local city. And these are the references.
Okay. Okay, thank you, ma'am. Now we have a presentation on evaluation of anthropogenic stress on Nathasagar wetland in Pathan, Maharashtra by Rahul Mahamuni. I request our team to connect him. Mr. Mahamuni, can you hear me?
Yes, madam. Yes, madam.
Yes, please complete your presentation in 5 to 7 minutes, sir.
Okay, madam. Yes, madam. Whether my screen is visible to all of you?
Yes, sir. So have you shared your presentation, sir? Share your screen.
Yes, yes, madam. So
No,
is
we
it
cannot
visible
see
now,
it.
madam?
We cannot see your screen.
Just a minute, madam. Is it okay, madam?
Yes, sir. Now it's okay. We can see it.
Okay, ma'am. Yes, very good morning to all. I am Rahul Ratnakar Mahani from Department of Environmental Science, Saraswati Bhuvan College of Science, Aurangabad. I welcome you all to my research presentation titled Evolution of Anthropogenic Stress on Natsagar Wetland at Paitan, Maharashtra. So this is an aerial view of the Natsagar Reservoir where I had conducted my research work, and its adjacent areas, especially the wetlands, which is the focal point of my research. As we all know that wetlands are among the most diverse and productive ecosystem. So there is also very much thought provoking situation nowadays. It has been arise as the status of the wetlands, it is getting declined day by day. So now why this research matters? So what is the objective behind this research? Though the main objective was to study the impact of human activities on the wetlands of Natsagar, a larger objective was to analyze the current situation of the wetland and stress on the fact why it is important to conserve it and to get it under the canopy of the Ramsar Convention, so that it will get benefit from its funds, which will get diverted from scientific restoration of the wetlands flora and fauna. So I will talk about the Ramsar Convention in more detail later. So studying the impact of this anthropogenic activity in the vicinity of the reservoir, it has involved studying the physical and chemical characteristics of the water. So all this research points to understanding of the correct strategy that needs to be applied for the conservation of the reservoir in terms of ecological sustainability. So our study area lies in the district of Aurangabad in the Indian state Maharashtra at a place called Paitan. So this is a satellite image of the location. We can clearly see the meandering path of the Godavari river that is going to get flow into the dams area. So study was carried out seasonally, spanning over 3 seasons: the summer, the monsoon, and the winter during the year 2015 to 2017 by collecting water samples from different stations at the Nath Sagar Reservoir's wetland. Three sampling sites selected were at the upstream location, namely Pimpalwadi, the water pump house, Kawasan; another three at the downstream area, namely Sant Jnaneshwar Udyan, Eknath Maharaj Mandir, Jama Masjid Ward; and lastly from the wetland area, namely Chanakwadi, Pategaon, and Wagadi. So this was done to incorporate as much diversity as was possible. Let's understand the area and the study in a little more detail. The study area is also called Jaikwadi locally. So the reservoir is located at around 100 km upstream at Paitan with a dam at a higher level having long canals and irrigation facilities. Mr. Siddiqui was the chief engineer of the project that was inaugurated on 24 February 1976. So the dam, despite of overflowing 18 times, has stayed strong. An ancient temple devoted to Sant Eknath Mandir, a beautiful garden in the vicinity named Jnaneshwar Udyan, coupled with the presence of a bird sanctuary. So it has caused a inflow of tourists to this place all over the year. We know that all the lentic habitats such as reservoirs, ponds, lakes, and wetlands are extremely important as they are endowed with abundance of natural resources and are home for a variety of flora and fauna, which includes a wide range of migratory birds too. So this Jayakodi sanctuary that is located in 30 islands of various sizes in the shallow waters, providing shelter to all the birds. So this sanctuary needs protection not only from the anthropogenic activities but also from the occasionally overflowing dam. So also human activities like large scale fishing that happens in these waters pose a threat to these birds as they get entangled in the nets. So their survival is also adversely impacted by the high levels of pollutants flowing into these rivers. So how did we proceed? Water samples were collected over a period of 2 years, covering the three main seasons. So to account for differences in water, we selected 9 distant and dispersed geographical sites as discussed in the previous slide. So from the upstream and the downstream area, and another 3 from the wetlands. So 8 physical and 15 chemical parameters of water were considered for the analysis, and we had also followed the guidelines for the procedures as defined in AFA, Trivedi and Goel and Kodarkar. So here is a list of all the physical, chemical parameters that were part of the analysis. So as we progress with the presentation, we will get insights into how they differ. So to start with, we conducted correlation to look if there is any relation existing amongst various physical and chemical attributes. So then an ANOVA was done to check if locality and season had any impact on the water quality parameters or attributes. And our analysis suggested that the water samples from all of the sites collected throughout the seasons of 2015 and 2016 show changes in the concentration values with changes in season and locality. And the corresponding data can be accessed via the links provided. So because of the time constraint, I am unable to show you the link. So all this prompted us to go for further analysis. So we start. So as we observe in this slide that turbidity level between upstream as compared with the downstream area and the wetlands was statistically significantly different. So this trend was same across all seasons. So next parameter showed that significant difference was total solids. Other parameters like the temperature, electrical conductivity, total dissolved solids and total suspended solids did not show any significant changes across the 3 main locations. So when turbidity levels were compared, we found significant increase in the levels in downstream and the wetland against the upstream. So moving on, similarly, we studied 15 chemical parameters. So 8 of which you can see in the present slide: pH, total alkalinity, total hardness, calcium, magnesium, sodium, potassium, and dissolved oxygen. So again, data was collected from all the 9 sites as I had mentioned earlier. So to account for variation, if any. So let's see what was significantly different. So as you see in the slide, we found that the total hardness and the calcium levels were significantly higher in downstream and wetland areas when compared to upstream. Potassium and dissolved oxygen values were significantly lower in downstream and wetland areas when compared to upstream. So in fact, highly less compared to area. It means the statistical test showed that the levels of dissolved oxygen was very much high, less compared to upstream area. So in continuation with the previous slide, we analyze the rest of the chemical parameters also, that is biological oxygen demand, chemical oxygen demand, chlorides, nitrates, phosphates, sulfates, and ammonia. So let's take a moment to absorb this slide. What we found is that all the parameters except phosphates has significantly higher levels in downstream and wetland when compared with upstream. So for phosphates, the levels were significantly higher only at wetland. So we conducted a survey to understand the crop yield pattern and get an insight into the anthropogenic activities which I had mentioned in my earlier objectives. So in the villages around the reservoir. So the questionnaire was printed in the local language, that is in Marathi, to aid better response for the Maharashtrian people. So the questionnaire asked farmers about their knowledge of the impact of anthropogenic activities on the wetland. It also had other questions ranging from farmers' financial status to irrigational facilities and the kind of support they had got from the government. So this table, which we are all seeing, it shows how various sectors are contributing towards the pollution of wetlands. Like all the 4 sectors, industrial, domestic, agriculture, and urbanization are responsible for discharging various types of harmful discharges, non-point source pollution, deposition of filth material, and siltation into the wetland area. So rampant construction is also adding to the woes here. So without the proper way of disposal, lack of a sewer system, the burden directly falls on the wetlands and its neighboring areas. So although tourism generates revenue for the local people here, it also brings with it uncontrolled levels of pollution. So more so in the form of plastic and other non-biodegradable leftovers like wrappers, plastic baggages, and food covers also. So these lie unattended forever. So all these activities are a growing cause of concern, and if still left unchecked, are bound to further deteriorate situation of the wetlands. So now I mentioned the Ramsar Convention at the beginning of the presentation. So let's take a quick look at it. So this will give us an important context to the whole research. So it is an intergovernmental environmental treaty which was established in the year 1971 by UNESCO. So which came into force in the year 1975. So it provides the framework for national action and international cooperation for the conservation and wise use of wetlands and their resources. So the question here now is that where do we stand? So well, India is a signatory to the Ramsar Convention. So in India, there are 43 Ramsar sites now. Just recently, Lonar Lake in our Maharashtra was added to the list. So here is a huge achievement for all of us. So this detailed physical and chemical analysis of the Nath Sagar wetland may throw light on the ground reality and draw attention to the requirement of its conservation. So these are some of the news cuttings. So the wetlands have been in news for many years. It is the source for electricity generation for the Python plant, all the more proving its importance. So the release of water from the dam is a good news not only for the lower areas but also because birds get back their low-lying wetlands. So I will conclude because of the time constraint. So most of the physical and chemical parameters were found to exceed the maximum permissible limits established by WHO and BIS. So the gradual increase in the alkalinity could be a growing concern from agricultural perspectives. The water's color and odor from many places was objectionable. Nitrates and phosphates which were found in excess could lead to eutrophic problems, that is eutrophication. The sewage seems to enter the landscape in multiple places, whereby accumulating in the downstream and the wetland areas. So which could be the reason behind the presence of dense bacterial populations and fecal contamination. So rendering the water in these places absolutely left it non-potable. So people residing in the neighborhood have very less awareness about the importance of a wetland and how their day-to-day activities like washing cattle, throwing garbage, etc. is making the wetland worse day by day. So after looking at just minutes, I will conclude, sir. So just after looking at all these parameters and studying their impact, we observed that many of them are beyond permissible limits. So there is an urgent need to probe the sources of these pollutants and find ways to control them effectively. So if an in-depth research like this be used to draw the attention of all concerned, the local, the authorities, and the nearby residents who use water from the reservoir for drinking purposes, we cannot only sustain the wetlands health, but also ensure a continuous and a steady supply of potable water for us. At the same time, providing a safe habitat for the flora and fauna. So something that is of paramount importance for maintaining the Earth's ecological balance. So this research could serve as an instrument to seek protection for the wetlands from a world-renowned organization like the Ramsar Convention. So here I end my presentation. So a big thank you to all for patiently listening to my research presentation. So the rest of the slides are documented data used to drawing conclusions we just discussed. So here with I end my presentation.
Yeah, thank you so much, Mr. Rahul Mahamuni. Our
Thanks,
next
madam.
next
Yes.
presentation is on a spatial interventions approach for restoring urban river linkages. Case of Varuna River, Varanasi by Aishwarya Dwivedi. I request our team to connect him. Okay, as Dwivedi ji is not in the meeting, we'll go for the next one. The next presentation is on SWOT-based hydrological modeling of Uttarakhand, Central Himalayan region, India by Ayush Vijani.
A very good morning to everyone. Am I audible?
Yes, ma'am, you are audible.
Okay, just give me 2 minutes. I'll just share my screen.
Ma'am, can you please on your camera, ma'am, so that we can
Yeah,
yeah.
yeah, okay. Yeah, okay. So my topic for the presentation is SWAT-based hydrological modeling of Uttarakhand, Central Himalayan region, India. I am Ayushi Vijani and I'm a PhD scholar from Terry School of Advanced Studies, working under the supervision of Dr. Vinay Sinha from Terry School of Advanced Studies. Okay, so first of all, the study deals basically with the GIS and how we can use GIS for hydrological modeling. So hydrological modeling is a prerequisite to water resource management and planning, as we all know. And this study has particularly employed using ArcSWAT, which is a GIS-based interface for SWAT model that aids in the creation of model inputs. The SWAT is your basically the soil and the water assessment tool, which predicts the impact of land management practices on the hydrology in small and large complex catchments. And it also helps the study of water balance in time domain, as well as it can be used as a tool to investigate the impact of climate change on the water availability around the world. And basically, in this particular study, what we have tried to do is that we have tried to calculate or basically assess a water budget, basically to by quantifying various components of the hydrological cycle using SWAT for ungauged catchments of Uttarakhand in the Central Himalayan region. Talking about the data sets and the methods that we people have used is for the DEM, that is the digital elevation model, we have used the SRTM dataset, which is at 30 meters, and basically we have created a depression-less DEM, or we can say a sink-free DEM. Then the physical parameters of the watershed, such as the flow direction, the flow accumulation, the drainage network, and the drainage slopes are also calculated. The land use and the land covers is one of the most important factors that basically affect the surface and the subsurface hydrology of a catchment. So that has been prepared using the Landsat 8 OLI satellite dataset for the year 2019, and to make sure that we are making the LULC very much accurate, we have used the forest dataset from the Forest Survey of India, and we have overlaid that particular class. And also we have basically tried to use a hybrid technology or a hybrid technique, which is involving the digital image classification as well as the visual image interpretation. Talking about the soil data, I have procured it from an open source website, which is the soil grid website at 250 meters from soilgrids.org. I've mentioned the website as well. Then talking about the climate variables, I have taken maximum and minimum air temperature, solar radiation, wind speed, relative humidity, precipitation. All the data sets have been procured from the IMD, Government of India. Now, talking about the methodology, now since SWAT model requires us to create or basically use the land use, the slope, as well as the climate variables. So basically, I have tried to map all the catchments using the India-Varis basin boundary that they are already providing. So it has been divided into four major catchments, that is the Yamuna, Upper Ramganga, Ghaggar, and the Ramganga. Since we all know that SWAT is a physically based semi-distributed watershed scale model, which has been extensively used to predict the impact of land management practices on the water. So that has been used, and what we have tried to done is that we have tried to create 4543 HRUs, which are the hydrologic response units, and we have generated these HRU from 558 subbasins from the year 1983 to 2019. So basically, being like a researcher, I was not able to get the data from the CWC because of the uncaged catchments, and also because of the data dissemination policy of the CWC. So because of the data limitation, I thought that okay, let me use the data set which is already available, by India Virus, which is freely available for all the scholars and I think for all the academicians to use. So I've tried to match my results with the dataset which has already been available on the open source. So this is the framework that I have used. Already discussed that I have used the land use, the soil, the SRTM, and I have tried to validate the model with the India Virus surface water audit dataset. And these are the four major catchments that I have used, and also the figure at the bottom. It is the 558 micro watersheds that I have used in the SWAT model. Now, talking about the calibration part of the SWAT model, I have used, or I have refer to the paper or the study which has already been published by Kushwaha and Jain in 2013. And this study is particularly, or the paper is particularly for the Uttarakhand. So basically, all the parameters talking about the surface response or the subsurface response, and lastly the basin response. What I have tried to do is I have used, or tried to use all the recommended range, and apart from the ranges, all the default values also I have considered, and all these parameters I have referred from this particular paper, and more or less I have tweaked these values as per my study, and I've tried to proceed and work. Also, as I was just referring, that I have used the data set from the India virus. So this is just the screenshot of the portal, and also how the data set was available. So as you can see, I have taken for all the district data sets that has been like for all the districts. They are giving the inflow and the change in storage and the total outflow. So I have taken this data set for the comparison. Then talking about the results and the discussion part, the application of SWAT model in Uttarakhand was basically challenged by the scarcity of data for the validation due to strict data dissemination policy of the CWC, as I just already mentioned, and that is why I thought that I should use the India virus dataset. So, as per the results, I can say that if we look at the three basic parameters, that is the inflow, the surface, and the subsurface outflow, sorry, and the evapotranspiration. So if I say that, if we look at the result that I have got from the SWAT model, if we look at the inflow, for my model, the result is 59.76 BCM. But if we look at the India virus, it says it is 55.91. So similarly, if we look at the other two parameters, I feel that more or less the study is, it is the comparison or the study is giving me good satisfactory results. So there's a good agreement between the two. Also, I have tried to match, the inflow district wise. So here, if I look at all the 13 districts of Uttarakhand, and if I compare the total inflow for each district. So if I look at both the India virus dataset as well as my modeled or the simulated results, so you can see in the graph also as well as in the table also, more or less the results are satisfactory. And also apart from Pithoragarh, or we can say Chamoli, there has been some sort of overestimation, I can say. But then I think in case if we are not having any data set, we can I think it's a good opportunity for all the researchers that we can use all these open platforms or geo portals for our study, and at least we can get an estimate or a rough idea of how well our model has been calibrated or tweaked. So based on these discussions and results, I would like to conclude that the study attempts to provide knowledge to estimate the water balance at a regional and a state level using the surface water audit dataset by the India virus. And also, this study provides a significant contribution to the state specific action plan for water resources under climate change, basically under the National Water Mission for the government of India for Uttarakhand. And also, the other states also where we have transboundary rivers, just like we have Arunachal Pradesh, and where we are not able to get adequate data set on the gauge stations. So I think we can use India virus well, and we can compare our data sets and our results. So this is the whole approach of the study that I have followed, and these are the references. And thank you. If there are any questions, I'll be happy to answer them.
Thank you so much, ma'am.
Thank
Okay.
you.
So we are going for the next presentation. The next presentation is on sustainable solutions to river pollution and rejuvenation by Dr. Shamoli Sen and Dr. Aghudip Dasgupta. Dr. Shamoli Sen and Dr. Aghudip Dasgupta, can you hear me? Any one of you?
Hello.
Yes, ma'am.
Yes.
Yes, please, ma'am. I'm requesting you to complete your presentation within 5 minutes, ma'am. Over to you.
Yeah. Should I start? Hello?
Yes, ma'am. Yes, ma'am. Yes, ma'am, you can
Yeah.
start.
So I'm going to speak on sustainable solutions to river pollution and rejuvenation. Uh, India originated as a fluvial civilization. We are not only dependent on rivers only for our food and livelihood, but our culture, our traditions, our practices, everything is dependent on rivers. At present, 80% of our population is roughly dependent on 14 rivers flowing through our country for food, livelihood, and other economic reasons. Ganga is now the most populous river basin and perhaps the most polluted also. So even now, the latest data shows
Sorry
that
to
there are
interrupt you,
seven.
ma'am. Dr. Shamoli Sen. Are you
Hello,
going to... Yes, ma'am. Are you going to share your screen?
I have already shared it.
No,
Is it
ma'am. We
not
cannot
visible?
see it.
Okay. Just a second. There is some issue here. Is it now visible?
Yes, ma'am. It is visible
Yeah.
now.
Yeah. Okay. So we know that even now there are 764 grossly polluting industries that are discharging around 500 million liters of industrial effluents into Ganga. There is similar situation of sewage dumping also into our rivers. So more than 2 decades ago, CPCB declared that the water we have in our rivers is not even fit for bathing. So such grim is the situation and it is very worrisome. So now we know about the issues, but the problem is what is the way forward? So here we have to talk about sustainable solutions, smart solutions, innovative practices that can actually make us wriggle out of this pollution situation. So coming to river pollution, we know that it is the unwanted addition of various pollutants in a river. So the major causes are agricultural runoff, which consists of chemical residues of fertilizers, pesticides, weedicides, etc. Also industrial effluent disposal into our rivers, sewage dumping, flooding and littering. Now, what are the types of river pollutants? So first is the solid form, which is trash and gross solids like paper, metal containers, plastics. Then second type is sediments and fine solids consisting of sand, grit, and of course all this adds to the total solid particles suspended over our rivers. Then the next are the category is the chemical pollutants, including types such as ammonia, detergents, fertilizers, heavy metals, etc. And the last one are the biological contaminants, which are mostly the sewage particles, including the fecal matter of animals as well as human beings. So all these are adding up to the river pollution. So now what are the effects of river water pollution? Now if we see that river is a system, then we look it from the sustainability point of view, we see that there are three goals of sustainable development: environmental, economical and social. And if we assess it from the sustainability point of view, the impacts that are generated by river pollution are also these three. Now, if we consider the environmental pollution, we see that there is destruction of biodiversity, contamination of food chain, destruction of aquatic habitats, damaging the flora and fauna variety. Then coming to economical, we have to bear heavy expenses on water treatment. Then there is also worsening situation of water availability as far as our agriculture and industries are concerned. And if there is health deterioration of a society, there is also a huge economic burden over the nation. So the third impact is social, which is perhaps most important. Firstly, there is deterioration of health of individuals as well as societies. Then there is lack of potable water, lack of water for other uses, plus the cost which is to be borne on such water availability is also very high. And there is also loss of aesthetic value when we have polluted rivers. And there is also a natural impact on tourism and other issues. Okay. Now, this is futuristic impact of river pollution. Now, when we say or when we talk of river pollution, it is not that we are dumping sewage, we are releasing industrial effluents. There is also a great synergistic relationship with much bigger issues such as climate change and global warming, which we can relate with river pollution. For example, with changing climate, we have erratic rainfall, we have erratic precipitation patterns, because of which the natural recharge of rivers is not being taking place. Plus, with rising temperatures, we also have greater surface evaporation. So all of which is impinging upon the river, the water availability in the river and the self-depuration capacity of the river. So superimposed over this situation is we have the dumping of organic and inorganic wastes which are actually being broken down, and it is these breaking down, like for example the anaerobic action and the aerobic action is releasing carbon dioxide and methane, and the denitrifying bacteria is breaking these matters and is releasing nitrous oxides. So these rivers are not only previously we used to think that they are sinks, but now they have become sources of greenhouse gas emissions, which is a really, really alarming situation. And in some studies which have been done abroad, like in China and Europe, it has been found that this greenhouse gas emission from our polluting rivers is actually 4.5 times more than that of the release of greenhouse gases from the atmosphere. So therefore, there is an emergent need to look into this pollution situation as far as global warming and climate change is also concerned. So this is some data which will show some polluting stretches of rivers in our cities. I'm not going into the details since there is paucity of time. So directly I will come into the sustainable solutions because that is what we are concerned with. So firstly, green infrastructure. So under green infrastructure, we can talk of development of rain gardens, constructed wetlands, and infiltration trenches. So this can be used for percolation through soil and plant uptake and transpiration. Then we can have preservation of natural floodplains and buffer lands so that we can store the polluted runoff. Then street sweeping. If we physically we separate the trash going into the rivers, then that can go a long way. Separation of sewer and stormwater lines is another important method which should be followed, which is not being followed currently in our city's situation because of the heavy load on our civic amenities. Since stormwater is not consisting of that much of impurities, so that can be easily released into the water bodies, but sewer consists of heavy impurities. So therefore in the situation of the gushing of water in both ways, so the sewer needs to be purified and then released into the water, and storm water can be released as it is. So there can also be minimization of the presence of impervious surfaces to reduce the runoff, especially in urban areas. Then introduction of plastic eating bacteria. This can be an interesting experiment that can be undertaken, since there are bacteria, forms of bacteria that can actually release enzymes that can break the plastic within 48 hours, and there have been experiments going on the world over. So we can also give it a try. Then other methods could be non-littering waste into the river, and of course planting trees. It has been seen that plantation belts around the rivers have actually reduced the incoming pollution of our rivers. So this is a numerical model which talks of a river resilient factor, or RRF. So I'm not going into the details. I'll just talk of what this RRF actually implies. A lower value of RRF will means that there is low resilience of the river to the anthropic sources. That means there is lower capacity of the river to purify itself, and a higher value of RRF means there is a high resilience and dilution effect and self-depuration capacity of the river. So this factor can be used to check our rivers whether they fall into the higher category or they fall into the lower category. So this was an experiment that was undertaken by us. This is fly ash has been used as a sustainable river purifying agent. Fly ash is a cheap alternative, and since it contains carbon, so it has water purifying abilities. And instead of using commercially activated carbon, fly ash can be used for absorbing impurities. And this was an experiment which was done by collecting a water sample between the Dakshineshwar and Dankuni stretch, which is one of the most polluted stretches of the Ganga basin. So here the water was collected from a garage which was the water had residues of oil, grease and other dirts. So this water was passed through a fly ash bed including geofibers sandwiched between geofiber mat. One can see the pics over here, and the water was purified, and the percentage removal was about 88 to 95%, although this depends upon various other factors also, the filter media, the absorbent dosage, the pH level, the contact time, etc. But the results were very satisfactory, and the byproduct that was left was a sludge, and this was a mixture of silt, clay and fly ash. So this sludge can be used to as paver blocks, and this since it is a combination of three things, clay, silt and fly ash, so this will have very high cementitious properties and strength. So this can be a very innovative and economical way of using the byproduct after the water has been cleansed through fly ash. So this is another pic which is showing that we can use screener belts to stop the flowing pollutants in the river. So the suspended pollutants can pass through a screener, and they can be stopped over there, stalled over there, and they can be physically removed as well. So this is another solution. So in conclusion, we have to actually, since the situation is very emergent, so we have to think out of the box. So one of the important things that we are proposing is eco-feminism. This was a term that was used by Francois Eubon, and it refers to seeing environmentalism as a relationship between women and earth. Since our rivers have all through been worshipped as divine mother, So we can involve women to be engaged in purifying our rivers, and the civil society can participate in a big way, just as we had chipko movement, so where the community participated and saved our trees. So similar things can be adopted in case of our rivers. So this is another model which we can say an advanced version of the sustainability model, the DPSIR model, which also can be used as an analytical framework for assessing water issues and purifying our rivers. Here we see that there are driving forces like agriculture, manufacturing, which are all contributing to river pollution. Then there are pressures of emissions, waste production, industrial discharges. Then we have situation of air quality, water quality, soil quality, which are all deteriorating day by day. And this is all impacting not only our health, but ecosystem health, environmental health. And we have to respond through laws, plans, rules. So since rivers are not legal entities, they cannot save themselves. We have to save themselves. So only if we save them, they can save us. So I will just end my presentation over here by saying that we have to think of situations, we can have to think of techniques, innovative solutions, smart solutions to bail us out of this situation. And I will end with this statement that by Oliver Wendell Holmes, that a river is more than an amenity, it is a treasure. It offers a necessity of life that must be rationed among those who have power over it. Thank you.
Thank you so much, ma'am. Well, we have done with all the paper presentation. I now request Dr. Piyush Rotela, Executive Director and Chairperson of this session, to come here and say a few words and sum this session up. Over to you, sir.
Thank you. We had around 3 plus 5, 4, 7 presentations in this session, both from seasoned researchers as also upcoming young researchers. In the beginning, Dr. Suchita, she talked about the vulnerability capacity of the people and highlighted the risk posed to particularly females and young children due to the livelihoods. I'll suggest if she particularly say determines, because she has both calculated vulnerabilities and capacities, if she comes up with a model wherein risk posed to different groups of the society is quantified. Then there was an interesting paper by Dr. Sujit Ghosh, which suggested online kind of platforms using machine learning and other things to say forecast, quantify the risk posed by floods and drought, and it could be an important tool for policymakers, as also for say coming up with better and innovative risk transfer say tools such as BMAS and other kind of say things. Then there was a young voice from Australia. She put forth her worries, her aspirations. Then Asha Rao she talked about the land use changes in Charkhi Dadri, anthropogenic changes around wetlands was talked of by Rahul Mahamuni. Ayushi Vijani, she talked about the water budget of Uttarakhand, hydrological modeling, how, say, her, say, study matches the results of India, Varis and other kind. Then in the end, Dr. Shambli Sen came up with interesting kind of solutions for minimizing the pollution, particularly the idea of using fly ash as also plastic eating bacteria. and Eco-Feminism, what she suggested for cleaning the or checking the pollution. That could be a long-term goal or long-term takeaway from this session. I thank you, thank all the presenters, as also all the audience for being patient learners, patient listeners. Thank you all.
Okay, so thank you so much, Dr. Piyush Rotela. Now we have a panel discussion, and the theme for the panel discussion is role of stakeholders in case of river rejuvenation and livelihood development. And for this session, I'd like to call up on stage Dr. Kalyan Rudra, Professor Mahalaya Chatterjee, Professor Kaushik Ghosh, Dr. T.K. Mandal, and Dr. S. Shamanto. Rudra, Honorable Chairman, West Bengal Pollution Control Board, Government of West Bengal. Dr. S. Shamanto, HOD, River Ecology and Fisheries Division, ICAR, Central Inland Fisheries Institute, Barakpur, West Bengal. Professor Kaushik Ghosh, Assistant Professor, Urban Management Center, Netaji Subhash Administrative Training Institute, ATI, Government of West Bengal. Professor Mahalaya Chatterjee, Professor, University of Calcutta, Kolkata. And Dr. T.K. Mandal, Research Officer, Scientist 3, Central Ayurveda Research Institute, Ministry of Ayush, Government of India. To felicitate Dr. Kalyan Rudra, I'd like to request our Honorable Vice Chairperson, Ms. Aparna Bera Roy Chaudhary, to come up on stage. And I request our team member to bring the mementos on stage. I request Ms. Bera to felicitate Professor Mahalaya Chatterjee, Professor, University of Calcutta, Kolkata. I request Ms. Bera to felicitate Professor Kaushik Ghosh, Assistant Professor, Urban Management Center, Netaji Subhash Administrative Training Institute, Government of West Bengal. Thank you. Okay, so now we have a special lecture on the theme Role of Stakeholders in Case of River Rejuvenation and Livelihood Development by Dr. Kalyan Rudra, Honorable Chairman, West Bengal Pollution Control Board, Government of West Bengal. Over to you, sir.
দেখি না অনেকদিন এমনি বলা যায় কিনা distinguished panelist, my young friend Vishwajit, members of this organization. I can see Taputidi here in the audience, and my dear friends. At the outset, I would like to declare that whatever I am going to say here, not as the chairman of the Pollution Control Board, but as an independent researcher. And my research on the rivers of particularly Bengal for the last 4 decades, I have learned many things. শোনা যাচ্ছে না? অসুবিধা হচ্ছে? This conference is, as I understand, dedicated towards the rejuvenation of Indian rivers. This is described as International River Congress. But as I understand, during my long teaching and research career, and also as the chairman of the regulatory board, which is also one of the stakeholders in river management, I find that, I learned that rather, there is a broad misconception about rivers. If I ask many of my students sitting here, can you define river? They will simply describe that river is a channel of flowing water. It has a source, it has a mouth, it has a right bank, it has a left bank. But river is something beyond that, something larger than this definition. The more scientific definition, as when I had been teaching in the class, I frequently say that please keep in mind, river is the terrestrial part of the hydrological cycle which is operating over the globe. More precisely, it is the runoff part of the terrestrial or hydrological cycle. River is not only the conduit of flowing water. It has 4 major components. First, definitely it is a channel of flowing water. Secondly, what we frequently forget, that it carries suspended load, that is suspended sediment load. It has also bed load, but suspended load is most important. Third is, river has the energy. That's why we construct hydropower project and exploit energy. And fourth one, which is grossly denied in our planning process, river is the biodiversity hotspot. So these 4 major components constitute a river: flowing water, suspended solid, energy, and biodiversity. The river management technique in India, particularly during the post-independence period, were borrowed from the British Institute largely. But if you compare the rivers of the Europe with that of India, they are broadly different. I just cite one example. Ganga Brahmaputra system carries so much of sediment, suspended sediment load, and discharge into the Bay of Bengal, which is larger than all rivers combined draining from Europe. And secondly, if you compare the discharge hydrograph, we often teach the students how to draw the discharge hydrograph, keeping the months on horizontal axis and flow on vertical axis. Rivers of this continent, this subcontinent, reaches the peak during July-August, when we get the monsoon rainfall. About 80 to 85% of the flow carried by the Ganga system flows during July, August, September. Remaining part, that is the remaining 8-9 months, we have 25% of the flow. And we often fight over the sharing of the water. Sometimes within the country, like the Kaveri water dispute, or sometimes internationally by the in the Bangladesh conflict over the sharing of the Tista or that of the Ganga, or we can also refer here many treaties signed starting from Mahakali's treaty with the Nepal and also the conflict between India and Pakistan over the sharing of the Indus water. The rivers of this subcontinent, while considering the management plan, we must understand the hydrogeological characteristics of the river. During the post-independence, post-industrial revolution in United Kingdom, the British engineers learned the better use of steel, steam power, cement, etc., etc. And a new engineering emerged in Europe, which critics described as the engineering of the command and control over the nature. A group of engineers had an understanding that we can alter the nature. We can change everything, and that too for the better common good. The engineers in independent India, coming out of the Thomson Engineering College, Roorkee, or IITs, or IIEST, they borrowed the same philosophy of the river management, of the command and control over the nature. But if you go back, the farmers of India, particularly the lower Ganga Brahmaputra plain, they had a different understanding about the river. I was reading an English translation of the laws of Manu. The Manu once said that he who dams the river, he who interrupts the flow of river should be excluded from the society. The farmers of Bengal, Bihar, and that of the Assam used to welcome the flood because they had a clear understanding that the flood is a sediment dispersal mechanism and it helps to renew the fertility of the soil. And this hydroecological relationship between the river and the floodplain agriculture was grossly denied or misunderstood by the British engineers. What they did, they had a dramatic lack of understanding how the river system operates here. They wanted to achieve freedom from flood because they saw that during the flood, the revenue collection system is interrupted. The Damodar was described as the sorrow of Bengal by the British engineers. But can you cite one such river all over the world, which is very rich in its coal reserves in its upper catchment, and lower part is agriculturally most productive? Hamilton wrote that lower Damodar, that is, he talked about Bardhaman district, ranks first in agricultural productivity in India, followed by Tanjore of South India. If you read the Aini Akbari, there is a paragraph, it says that the floodplain of the Ganga is so productive, it can produce 3 crops in a year. And a single grain could produce 2 to 3 shades of rice. Such had been the understanding of our farmers about the rivers. But Damodar, which gave prosperity to the Bardhaman district, was unfortunately described as the rivers, as the sorrow of Bengal. And so also the Koshi was described as the sorrow of Bihar. But they did not understand the flood has many ecological roles. It flushes the sediment load. It disperses the sediment load and renews the fertility. It helps the floodplain agriculture. It protects the biodiversity and many other roles. So what they first did, with a dramatic, I repeat, with a dramatic lack of understanding about the river system, how does it operate, they embanked our river system. The first river which was tamed was Damodar. It was initially embanked on both banks, and subsequently the right bank embankment was demolished to protect the Panagarh Army Estate, GT Road, and the estate of the Maharaja of Bardhaman, because he was a very powerful man. The right bank was strongly built because the flood used to de-link the railway line and the national highway. So the rivers were embanked, not only the Damodar, but also Kasai, Ojoy, and many other rivers. This we describe as the horizontal disconnectivity of the river from its floodplain. The floodplain was disconnected from the river. It was delinked. The flood water, which used to spill off during the flood and leave behind the fertilizing silt on the floodplain, giving the agricultural prosperity, it was compelled to flow within bank to bank. And sometimes it breached the embankment, sometimes it overtopped the embankment. It was earlier 2 days flood. If you go to Bihar, the farmers say that it was do din ka bar. But when the railway lines and highways were constructed, it became 20 days flood, because the passage or flood flowing channels as well as the route were blocked. If you look at the railway map of West Bengal, one line going from Howrah to Bardhaman, then to Sahibganj, how many rivers it crosses? Starting from Damodar, Ojoy, Moirakhi, and many other rivers. All east flowing river coming into the Bhagirathi Hooghly River are intercepted. If you look at the North Bengal National Highway and the railway line, it is an east-west system, and all Himalayan rivers are coming south. So after construction of the railway line and national highway, the flood intensity increased. Bentley was the first engineer to describe how the Bengal ecology deteriorated, the agricultural system collapsed. It was none other than Meghnad Saha. He wrote that if there is anything called justice in this world, the people of Bardhaman and Hooghly are entitled to get compensation from the railway authority, because it changed the entire hydroecology. Acharya Prafulla Chandra Rai, in his book, Life and Experience of a Bengali Economist, after the disastrous flood of 1922 in North Bengal, he said that this government is criminally and willfully responsible for this flood. Yes, I understand we need railway. Yes, we understand we need highway. But I advise them to keep wider culvert and bridges. But they made it narrow to save the cost. And that choked the channel and the flood water outlet, converting 2 days flood, do din ka bar, to 20 days flood. So everything changed. The Bardhaman, which could feed the entire Bengal, suffered from famine in 1863 after the railway line and highway was built. And if you look the earlier history, the Mughal emperor said the Bengal is the paradise of India because of its agricultural productivity. So this changed everything, because of this horizontal disconnectivity of the river from its floodplain. Subsequently, the longitudinal disconnectivity was initiated. The British realized that the flow in these rivers of subcontinent is spatially uneven and temporally skewed. What they wanted to do, they wanted to store the water with the apparently pious intention of ensuring irrigation. So they built some low structure across the river, what we called weir or anicut. So like one you can see in Mohanpur across Kasai, another at Rondia in Damodar. And they excavated Eden Canal. One of farmers of Bardhaman, he is 80 plus now, he gave me a very good lesson. He said, sir, I can remember when flood water used to come in my agricultural field. It was red. It was rich in sediment load. And now the canal water of DVC coming to my field, you look at that, it is transparent because we store the water for 3 months on the reservoir and then release it, leaving the sediment load on the reservoir. So that is free from any sediment load and nutrient. So when Bardhaman suffered from famine, Radha Kamal Mukherjee, in his Changing Face of Bengal, he said, this is red water famine. The rivers are deprived of sediment load. And this is because of the reasons the Ganga is also tamed at many places. Starting from Haridwar down to about Farakka, the Ganga earlier carried about 800 million tons of sediment load in early 1980s. Now, when I had been working with the consortium of the IITs, we find that the sediment load at Farakka point is 170 million tons only. This drastic reduction of the sediment load of the Ganga and its distributary system has changed the hydroecology of the Sundarban also. The wave is continuously in spite of receiving highest sediment load in the world, the delta is not growing southward, rather the sea is encroaching inland. I was just seeing a paper that how the Sagar Island has been reduced substantially. Since I was working on the James Reynolds map of Bengal, it was published in 1780 from London. Comparing that with the recent satellite image, I see that the sea has encroached by about 8 kilometers since 1780 along the Sagar Island. So this longitudinal disconnectivity was made by the rivers, by the dams. The post-independence era witnessed large-scale dam building. And the river basin was divided into two parts, upstream of the dam and downstream of the dam. The community who were largely displaced were the tribals. Who raised the voice first against this displacement and large dams? Is it Narmada Valley from Narmada Valley? No. It is none other than Rabindranath Tagore, who wrote Muktodhara in 1922. উজানের একদল মানুষকে বঞ্চিত করে তুমি নিচের দিকে জল দিতে চাও? He realized that we are disconnecting our river system longitudinally. 19th century, after the Industrial Revolution in UK, we witnessed two major geographical change. One is rapid urbanization along the bank of the Ganga. Second is industrialization, like that of along the bank of the Hooghly. In absence of any regulation, because my colleague Dr. Saha knows, the Water Act was first implemented in this country in 1974. Before that, we did not have any regulation. The rivers were used as the most convenient outlet of the wastewater, not only from industries, but from the urban centers too. The Central Pollution Control Board has identified 118 major drains discharging wastewater from, 138 major drains discharging from 118 major towns developed along the bank of the Ganga, from Haridwar down to Ganga Sagar, discharging 6,000 million liters of wastewater into the river. Long back in 1985, our former Prime Minister Rajiv Gandhi realized that it should be intercepted. But we find that after about 3 decades or 4 decades, there was no appreciable change in the water quality of the Ganga. Subsequently, the Namami Ganga project has also intervened. More than 350, if my memory serves me right, river stretches of the country was described as the polluted stretches. And 17 such are in West Bengal. It includes the lower part of the Ganga from about Tribeni down to Uluberia. If you look at the dissolved oxygen level, BOD load, and coliform bacteria count, yes, we have achieved some improvement after the Namami Ganga project, but in terms of DO, dissolved oxygen, and BOD load, but coliform bacteria count is still alarmingly very high. So, who will take care of our river? Who are the stakeholders? There are many. It is Central Water Commission, MOFCC, Central Pollution Control Board, State Pollution Control Board, State Irrigation Department, NHPC, UDMA, Urban Development and Municipal Affairs. I also like to include IMD and finally the NMCG. The concept of river management, I would like to say that we have a gross misunderstanding. That I was talking with about 3-4 years back, Ramaswamy Iyer at Delhi. I met him in Delhi. He was the secretary to the Ministry of Water Resources. He said, he died about 2 years back. He said, Kullan, when I joined Central Ministry of Water Resources, I was given an understanding that more water we take away from the river, more we ensure irrigation, more will be the GDP growth, more will be the development of the country. But after working for more than 50 years, I understand that no, I had a misconception. More water we allowed to flow through the rivers, more we gain, because river renders many apparently invisible services to the ecosystem and society. Our climate is fast changing. I had been working in the many parameters of climate change, particularly in the lower delta. I find that our rainfall pattern, there is a tendency of delayed monsoon, there is a tendency of short duration intense rainfall that will lead to two hydrological extremes. One is flood, other is drought, water shortfall. The farmers will more and more rely on groundwater, but groundwater is depleting in the lower deltaic plain at the rate of 20 centimeters per year. We have problem of arsenic contamination, we have problem of fluoride contamination, we have salinity, we have a complex situation. More important is what we normally forget, the base flow towards the river. This is an apparently invisible flow from groundwater towards the river during the lean month has gradually disappeared. So many rivers have gone dry. We have exploited so much of water that many rivers have gone dry. If you look at the discharge hydrograph of the Ganga, there are three major components. You will find rainwater in the river from June, July, August, September. These 4 months, the river will reach its peak. It will overtop, it will erode its bank, etc., etc. But when there is no rainfall, who keeps the river mobile or flowing? It is the groundwater flow, that is the base flow. But because of the over-exploitation of the groundwater table, this base flow is being reduced. It continues from October, November, December, and subsequent few months, but because of the agricultural sector, we exploit, and it has reduced substantially. From late March onwards, it is the snow melt water coming from the Himalaya that supplies water to the river. So there are three major components of the water in river. One is rain, second one is base flow from groundwater table, third is snow melt water. But if you look at the peninsular river, the first day, honorable technical member of the NGT raised the question, why all rivers are not perennial? Because the South Indian rivers do not have the snow melt water supply. It is the Himalayan rivers which is. So nature has a unique balance. So we'll have to rethink. We'll have to understand holistic eco-hydrology, how the system functions, how the hydrology operates in this country. And most important is the greater common good of society and the ecosystem is not exploiting too much of water from the river, making it totally dry, but find a rational, explore a rational meeting point, how much water really we can exploit from the river and how much water we can allow to flow. This is the concept of ecological flow. Ecological flow is not based on arithmetic hydrology, say 20%, 25%, 30%, 40%, we will just allow. It is an holistic eco-hydrology. You will have to understand that not only the human society, the biodiversity has equal right over the water. And I conclude saying a few words from my very favorite Barry Commoner, he wrote a book called Making Peace with the Planet. He said the 4 laws of ecology governs your existence. First law, you are living in an ecosystem where everything is connected to everything else. Second law, it's a dynamic system. Everything must go somewhere, like the river. Third law, whatever you do, there is a cost. Not only economic cost, but also ecological cost. And fourth law is very close to my heart. Nature knows the best kind of engineering. And this is the new concept emerging in Europe and America, what they call ecological engineering. You will have to understand the balance of the nature and intervene accordingly. Otherwise, you will just perish from this ecosystem. Thank you all for your patient hearing.
Thank you so much, sir. Now we are going directly for the panel discussion. I request Professor Mahalaya Chatterjee to chair this session. Over to you, ma'am.
Good afternoon, everybody. Now this is a panel about the stakeholders of the river. And I think I am the odd man out because what I have done all my life is to deal with urbanization and urban issues, and which is to be blamed for the distressful condition of the rivers. Whenever I go to, say, Europe and America and then come back, then I really feel that what we have done to our rivers. Our rivers have turned into drains. And sometimes it may happen whenever I go to a new place and I make it a point that I don't want to go anywhere, but if you have any river or lake, I want to go there. And sometimes it becomes like Yarrow visited because of the pathetic condition of the rivers. Anyway, so we have a panel which has a variety of known people famous in their own look. This is, there is Dr. S. Shamanto, which is head of the department, River Ecology and Fisheries Division. That is the Central Inland Fisheries Research Institute of Barakpur. Then we have Dr. T.K. Mondal, which is the Research Officer, Scientist 3, Central Ayurveda Research Institute, Ministry of Ayush, Government of India. And then we have Professor Kaushik Ghosh, who is the Assistant Professor of Urban Management Center of Netaji Subhash Administrative Training Institute, Government of West Bengal. And of course, I am there. I would be doubling as both the chairperson and also a speaker. So I keep my chairperson's privilege. I will talk at the last. Then I would request Dr. Samanto to make his presentation.
Good afternoon to all of you. Actually, the presentation is that of my director. Unfortunately, he is out of station. So I am taking the responsibility of giving the glimpse of the Namami Gange project, its output in the institute at Central Inland Fisheries Research Institute, Barakpur. This is basically the Fisheries Institute took birth in 1947. Next, please. And it worked on inland fisheries. And there was another institute for marine fisheries. It was at Kochi. We are fortunate that during 2020, this institute got the Sardar Patel Best Institute Award among the ICR institutes. This is the institute, its main building. Next, please. Sir, I am just telling about the role of fisheries in sustenance and improvement of livelihood in Ganga River system. Next, please. These are the components, different components of the project. I am not going into the details of that. Basically, the different forms of fisheries and its role to improve the livelihood of the system. Next, please. This is continuation of that. I am not coming into detail of that. Next, please. These are the team of workers from our institute. A number of research scholars are also working. Since Ganga is the longest river of our country, it is a blessings rather for the country and for this region, because of Sir has nicely pointed out the role of flood and all those for the productivity. In water and sediments also, there is lot of thing it has given the river Ganga. I am coming to that. Next, please. These are the sampling sites over River Ganga. From 16, this project is in operation. 19 stations are there in the river stretch. Next, please. So in the water and sediment, I would like to mention the highlight only. Next, please. These are the parameters we used to study in the physicochemical parameters of water and sediment. Next, please. Sir, the river water has very good pH, always above 7.5, and it is going up to 9.4. And the next interesting thing is that, next please, it has good conductivity, alkalinity, and hardness. This is the unique river among all the 14 major rivers and small rivers also. It is having very good alkalinity and hardness. This is the major cause of having very good productivity of water of River Ganga, and we are also blessed with production of that. Next, please. It has good dissolved oxygen, always, majority of times it is above 6. Among the sediment is also of having higher pH of alkaline range. Next, please. Of course, in the organic matter content, in the polluted stretch, basically there are some accumulations, and we are getting value above 1%. While in the upper region, mostly it is sandy, means organic matter content is very less. Regarding pollution status, Sarah has nicely pointed out about the BOD and COD. Here, just have a look. It goes, yes, we consider 3 as the limit. When it is above 3, there is organic matter pollution. Sir has nicely mentioned that, yes, it has improved. With the Ganga Project Directorate, then Pollution Control Board, then our Namami Gange. Sir, I can tell that, yes, there is drastic increase and development in the system. Sir, you just consider about the population of the basin, how much it has increased. It has gone at least 2 times. Then where the effluent will go? This will come into the river system. We have the sewage treatment plants, but the unfortunate irony of our system is that many times, electricity failure is there. It is not operating properly, so it is coming into the system. But I thank the Namami Gange and the entire team who have worked on the system earlier that, yes, there is no deterioration of the system. Rather, there is significant improvement in oxygen content, in BOD level also in many occasions, even in Kanpur and Varanasi stretches. Next, please. COD also. Sir, the unfortunate thing is that microplastics and its pollution, if I don't mention, it is a horrible situation now. Our studies tell that we get more of plastics rather the fishes. This is some real pictures. Just see, dump of plastics in bagnet fisheries and very little amount of fish in that. Next, please. I'm coming to fish and fisheries, our observations, major observations. In Namami Gange project, we could record 190 species. Just have a look. In some of the cases, the number of species is relatively more. Actually, it considered the total basin and also Bangladesh portion. With respect to that, our biodiversity is rich. Next, please. Yes, among the fishes available biodiversity, some are endangered, some are vulnerable. I have mentioned some of them. Tor pituitora, commonly known as mahasir, yes, it is in endangered condition. Then Schizothorax, in the upper portion of Ganga, it is vulnerable. Next, please. These are the biodiversity status along the river Ganga at different sites. It is quite natural that upper portion should have low biodiversity. Gradually, as we pass, biodiversity increases. In Godakhali, number of species recorded is less. This is of real concern. Actually, this is the intermixing zone basically. Gradually, after that, salinity increases. And at Frizerganj, it is quite natural that due to marine fishes, migrant fishes, its biodiversity is more. Next, please. We study the index of biotic integrity, IBI, means basically we use fish as the model to understand what is the situation. The study is continuing, and our earlier study indicated that among the 8 sites, the middle portion basically is having low biodiversity, and IBI also, I mean, moderately the sites are impaired, middle portion. Sir has rightly pointed out that water availability is low in that zone during non-monsoon seasons. It is also one of the reasons for that. Regarding exotic fishes, yes, in the system, 8 exotic fishes have been recorded, and some are, of course, notorious in the middle stretch, especially the common carp and tilapia. These are discriminating. I mean, these are gradually coming up, and our major resource, important resource of Indian major carps, katla, rohu, mrigal, its population is going down. When we compare the catch, basically we have seen 10 to 20 times decrease in catch is there, and also with respect to quality. Basically, whatever catch we get, those are mostly in miscellaneous nature. We are not getting catch of Indian major carps nowadays. Next, please. These are the distribution of exotics in the stretch, different fishes. Even pterygoptes we get, I mean crocodile fish we get in River Ganga nowadays. It is of concern definitely. Next, please. Yes, we use different destructive gears for catching our fishes. It is of real concern. You just see, I have mentioned a little bit about hilsa here. All the small juveniles of hilsa are caught by this type of different destructive gears, so that the average size you just see here only 4.2 gram. Just imagine all the small juveniles are caught. When from our institute, we are telling that hilsa must be caught by gill nets of 90 mm size, but here you just see the size of the, gears operated. All the small hilsa juveniles are caught in the system. When we joined in our research institute in 1995, in that time in Farakka, just below Farakka, tons of hilsa juveniles were caught, and those were truckloads. How much is its price? Very little, but the destruction is havoc. And now, I'm coming to the next one, please. This is the situation regarding hilsa. The red portion is from sea, and green portion is from the inland catch. Just see how with time it has vanished. And the blue is the total. So basically, whatever hilsa catch we get, it has dwindled to a great extent. Actually, hilsa has a peak. Every 10 years, there are some peaks. We get bumper catch. Then we think that our fishery is good, but it has really dwindled. And the irony is that during last monsoon period, there was no breedable hilsa fish. We have studied throughout the period, and we couldn't get it. Just imagine the situation. We have some other projects also. We are working on that. Next, please. Regarding spawn perspective, actually, in our country, 90% of the spawns was provided by River Ganga for our country. But nowadays, next please, there is significant decrease in spawn with time. Just here I have mentioned up to 66 to 75, there is gradual decline. And now there is no commercial spawn perspective from River Ganga. It has vanished. So just imagine the situation. Next, please. So our approach is, we are collecting the brood fishes from River Ganga. We are growing those in our ponds at different locations, and we are ranching to rejuvenate the depleted stock. Next, please. Next, please. Quickly, I will go into that. This is the technique. Hypophysis, then pituitary extraction, injection, and then this was our technique. Basically, our institute has given this technology. So for this particular technology, basically, inland fish availability is still good. Next, please. These are rearing in the ponds. Then next, ranching at different locations. We have ranched up to 42 lakhs in last 3 years. We have ranched in 45 occasions. Next, please. So these are the ranching, some of the photographs, some of the glimpses. Many important personalities joined us. Next, please. Next. some awareness programs from our institute. Next, please. Quickly, you can show the slides. These are the awareness programs we mostly held in our through our institute mechanisms. Next, please. At different occasions. Next. Yes, these are some of the publications. Yes. Thank you. Thank you.
Thank you, Dr. Shamanto, for this nice presentation. I would now request Dr. T.K. Mondal to deliver his speech.
Namaskar. Good afternoon, everybody. All the dignitaries on the dais and on the audience. Our expected Kullan sir, Dr. Samanto, Professor Chatterjee, Professor Ghosh. This is one of the privileges. I am introducing a different system that I use to overcome and strengthen the livelihood. So I use Ministry of Ayush that deals with the medicinal plants. You know that in Gangetic region, more than 1,000 medicinal plants has been found earlier. And all over these plants, presently there are so many destroyed due to that unawareness and the uprooting. So what is the relation between medicinal plants and this seminar? Because of this, the International River Platform, I am privileged to speak some words. And I am also thankful to Dr. Bishrit Rai to give me this opportunity. Because of any ethnic community that's developed in India nearby river basin. So many ethnic communities still now they are using the medicinal plants and are also using the mainstreaming of their treatment. Nowadays, more than 70% medicinal plants used by these village populations for the primary health care. Now, the present situation is that in Gangetic region, you see so many medicinal plants nearby in Bengal, rare endangered medicinal plants they're destroying due to lack of knowledge. In the recent corona situation, you know that simple tulsi. Because of the tulsi of Bengal, this is one of the best variety that is supplied all over India, and that is growing in the Gangetic basin. And so demand is so much high, they are not cultivating and not meet the demand. So Ministry of Ayush, they have taken one initiatives to awareness for the cultivation of medicinal plants. So not only for the health, but that is also enhance the economy as well as that maintain the ecology and the pollution of soil, water, which are based by the river. Because of so many medicinal plants, if you cultivate, there's not need to fertilizer or any chemical. Whereas the common crop, they need and they use a huge number of fertilizer as well as the pesticides that causes the soil pollution and ultimately the water pollution, and which causes the river and other water pollution. So if you cultivate the medicinal plants, so we can, three ways we can get the benefit. Number one, that increases the economy. Second one, that reduces the pollution. And third one, the awareness of health as well as the common diseases. Some medicinal plants are mainly present in the Gangetic region. You know one plant, their name is that Desmodium gangeticum. I think you have heard the name of this Doshimal edister. That is one of the major ingredients of the Chyawanprash. So now this plant is rare endangered. So if we conserve these plants, that will be one of the major things, and that only grows in the Gangetic region. That is the name is Desmodium gangeticum. In such so many plants that Marcellia minuta. In common, we tell that Susni. The Susni variety of Bengal, this is the best in India. But now, the cultivation procedures and different matters, they are not growing in proper way. Bacopa moneri, that called Brahmi, one type of vegetable, we take it vegetable. This is one of the best drug for the cognitive activity and the brain and memory enhancer. And that drugs, the best in India compared to other part. So these type of medicinal plants, these are destroying and not properly cultivated due to lack of knowledge and awareness. So if you introduce these plants and we can make their availability and their sustainable uses, so that can be a good initiative to all the society and that improve our systems. If you, in regarding one thing, say that in Ganga, after the Faraka berries, my home is nearby Ganga, in Katwa, that is district Bardhaman. So, in our childhood, we have seen that the flow of Ganga was left side. But after that Faraka berries, the flow of the Ganga, that's entirely in right side. So, that rivers goes right side in the land area and destroying more than up to 4 to 5 kilometers they have gone to the district of Murshidabad and Malda. You have seen that so many villages are destroyed by this Ganga. They have gone to this Ganga. And another way, in the left side, left bank of the Ganga, they are creating several barren land. And that land is very much fertile, and we can select that land and we can cultivate some important and rare medicinal plants. That will be a major important for demand of current situation. Because of that medicinal plants and IU system, that is not only important for this India, but also globally that is popularizing, and more than 196 countries, they are trying in collaboration with India to adapt this IU system of medicines and this Ayurvedic system. But we are not so much in situation to meet the demand for the genuine and original drugs because of the cultivation, proper cultivation, scientific cultivation is not in systemic way. So that's a big platform if we can select. Now India government, the Minister of Ayush constituted one board, that National Medicinal Plant Board, along with consecutive the State Medicinal Plant Board. So they are conducting this cultivation of medicinal plants. So many projects and schemes is there. So if you introduce implementing these schemes to the common farmers for the cultivation of medicinal plants, so that will be a great improvement. And that medicinal plant which are mainly present in the Bengal, so they will be make a good demand as well as make the system. Another thing is that our farmers and we are all the common people here don't aware about the medicinal plants as well as our health. So many common medicinal plants is there. If we use regularly, so we can prevent so much disease. And we not need to go for the direct allopathic medicines. In such a tulsi, Vasa, in such, that's Brahmi, Susni, even that Sojina, Sajan jeta boli amra, Sojna. These are the major important medicinal value, but the lack of knowledge, we are not using these medicinal plants. You know that another medicinal plant is Guruchi, that called Gulancho. This is one of the most immunomodulator. In the situation of the COVID, that major cause is the lack of immunity. And that medicinal plants, that Guruchi, that enhance the immunity and one of the best drug for controlling that COVID system. And now we are, the Minister of Ayush, we are also using this medicines as a Guruchi Ghanavati for prophylactic doses to control the disease. So that Guruji, if we take fresh, the stem juice of this plant or leaf juice of the plants, this is one of the most immunomodulator. But That simple knowledge we don't know, and the awareness of this lack of awareness, these things are gradually destroying. And now that plant is also one of the rare plant. So in this platform, my view regarding that medicinal plants and the river and the water both are equally important. Water is the for sustainable, for the living of our basic requirement, and plant is for sustainable of life. So if we can conserve these plants and award these common people, so that will be different way beneficial for all. So in this way, if we make this some collect an MSCP, that state medicinal plants also produce some MSCP, medicinal plants conservation area. So if you collect and select some MSCP area and cultivate these rare and endangered medicinal plants, so that will be improve our system, as well as the economy will be developed, and the general awareness and health will be also important for this purpose. Thank you all.
Thank you, Dr. Mondal. Now I request Professor Kaushik Ghosh to deliver.
So hello and good afternoon to the dignitaries on dais and the learned audience. I am Kaushik Ghosh. So it is wonderful to have a panel discussion because it is very thought-provoking, and I will share some thoughts and insights into the topic of the day, which is stakeholder participation and livelihoods development in relation to river rejuvenation. Now, if we go back to history, we will find that there were rivers. The rivers came first, and the human settlements followed. The human settlements usually targeted the rivers as suitable sites for proliferating, and they used the rivers, as we know, mainly for water consumption purpose and some other activities. But later, commercialization and use of the rivers happened in the form of transportation and fishing and entertainment, recreation. Now we fast forward a few centuries and we find that the rivers are still there. The settlements have massively exploded and expanded, and we have the rivers and all other related water bodies in the urban areas, not as merely cesspools of sewage. It's all black, and that's what we have seen since we are children, that canals and rivers are meant to be black, because they are meant to transport wastewater. And it has gone very deep into our psyche. Also, the connection to the river, a big river like Ganga also, is lost to many who reside in the urban areas. For example, in Kolkata also. The Kolkata riverfront, if we take for example, you will find that the riverfront is entirely walled up till a few years ago also, with mostly warehouses which were used by the British for transportation and storage. And the city got a peak of the river only through a few ghats, and select people who lived nearby the river were in close contact with the river. The rest were actually segregated from the river, and they led a different urban existence, because rivers meant for supplying water was no longer a reason for staying close to the river. Water supply happened through centralized channels, through exploitation of groundwater, and the river somewhere lost its purpose. So in present urban areas, we will find different categories of water bodies. We will find lakes and ponds and wetlands, and even urban flooding, if you consider it to be a sizable amount of water body, it is also a water body. And these water bodies vary based on the flow and the size of the water body, but they have one similarity, and that similarity is they are all very dirty. And it is wastewater which is, all these water bodies are more or less treated as outfall for different kinds of wastewater. Now, when we shift the topic to the stakeholder participation and livelihoods development, livelihoods development in relation to the rivers is still happening. Although, as we see that the fishery industry is badly compromised, as we just heard, and overexploitation is dwindling the resources. Now, there are many, if you Google or do YouTube about river rejuvenation, you will find plenty of videos which talk about the community which has helped in restoring the rivers and rejuvenating. But what is the size? What is the size we are talking about? And who are this community? And what is their stake into it? Who are the stakeholders? So if we start finding the stakeholders and start this community-based approach, it is certainly an approach. Many people have done it. But is it enough to change the current dynamic is a big question we should ask ourselves. I don't think it is enough to change the dynamic, considering the volume of wastewater that flows from the urban areas and the industries into the rivers. Hence, a more centralized, or I should say a more planned and integrated approach is required to address this issue. Urban local bodies operate within their boundaries, and they have their own projects to take care of, which may have some side effects on the benefits of the river, but it is more to do with riverfront development, which they are interested in. Riverfront development is not equivalent to river rejuvenation. Stakeholders are more dependent on riverfront development and the activities that go alongside the river. Even transportation or ferrying across the river is a commercial activity which is practiced widely, but that has really got nothing to do with the quality of the river. So whatever water flows, whatever quality of water flows in the river is of secondary importance, but it is time that it should be given a priority. Suppose we change this paradigm of thinking the rivers as outfalls, massive outfalls for our shit. We have one good example in the form of the East Kolkata wetlands, which is also facing threat, where luckily due to the gradient of this city, the river is on the higher side and the city drainage flows naturally to the East Kolkata side. And we have these wetlands where they are harnessing the river, harnessing the sewage, and they are doing something productive out of it. For example, using it for pisciculture or agriculture. Now, with the advent of industries, the leather industry and that heavy metal concentration in the wastewaters, that is increasingly being threatened. What if we stopped throwing the water into the river channels? What if we tried to create some wetlands out of the surrounding spaces based on the flow of that region and tried to leave the river alone for some time so that it could rejuvenate? There has been instances worldwide where lakes and seas have been overexploited, and when there was nothing left to exploit, people left them alone, and over a period of 10 years or 15 years, they have rejuvenated. And the same can happen to a river like that. The purpose of actually throwing water into the river or putting water into the river is to maintain its flow, nothing more than that. It is not meant to carry all our contaminants into the river. Because here it is not just the river, but the marine biota that we are talking about that needs to be also addressed, like the fish, as Sir was talking about. So if we take some examples worldwide, there is one good example I can think of that happened in Metro Manila, where the Pasig River was a small river compared to the rivers we have here, but that was rejuvenated involving the local people, the young people, through capacity building, and they have maintained it because they have understood the utility of maintaining a clear water channel. Somewhere that understanding and that awareness needs to be done, and it is a mitigation measure that we all need to address. It is no longer about engineering projects and environmental control only. It is also about creating this awareness among the people that it is not a backyard thing. The river is a very much part of our lives. And also considering the stakeholders, there was an interesting study which was conducted by GIZ a few years back, where they surveyed 7 cities in UP and Bihar. The religious institutions they studied, 183 religious institutions were studied, about the role in influencing the river management. Because as we know, most religions, all religions actually, espouse the practices of sustainability, where you are supposed to protect nature. And also, the religious institutions have considerable influence over the mass psychology in our country. Now, simple acts like throwing the deity into the river, or immersing the deity into the river, or throwing the flowers into the in a regular basis, that creates a lot of problems. But the survey interestingly found out that only 6% of these 183 religious institutions actually did something to do with the river. The rest had nothing to do with the river. So this is one area of stakeholder participation that I put forward just as an example that how really the awareness in this situation is. Another example, I would say that in order to sustain something, we all know that it cannot be on an ad hoc basis or till the funding lasts. Somewhere mainstream commercialization has to take place. Otherwise, the mainstream commercialization itself is a practice of sustainability. So many countries have identified those. We can learn from them. We can customize as per our needs, and we can incorporate them into planning. But planning is missing. And in this regard, I would like to thank NIUA and NMCG and Ministry of Jal Shakti, who has taken this positive role in envisioning this urban river management plan. I am sure it was shared yesterday. So this is a very integrated plan that has been envisioned, but if managed properly, maybe this can lead to good results. And stakeholders and livelihoods will also be rejuvenated along with the river. So thank you very much.
Thank you, Kaushik. Now I take my chairman's privilege to discuss some of the issues with you. So first of all, let me thank Saiard and of course the partners, the knowledge partners, the otherwise partners for bringing up such an important issue of rivers in the midst of an urban area. Now, let me start with taking a broader view, that if you want to know who are the stakeholders for the river, my answer would be everybody. Everybody. Because river, as like any other environmental resource, is the so-called source of everything, source of every resource and everything. But unfortunately, it also acts as a sink. And thirdly, as like any other environmental resource, it is also the source for many other things. Many other things, as it provides a beautiful view of landscape, tourism, then it is commercially used at transport routes and others. We have from a long time, starting from the days of the Phoenicians, there were ports on the side of the rivers, then small market towns which we call gonjos in Bengal. Everything was situated along the rivers or its tributaries or distributaries are everywhere. So as still we cannot create water, the basic thing which is needed for human survival, everybody is a stakeholder. In case of a river, it is concerned. But if you look at our planning process for the whole thing, that if you, Professor Rudra has very lucidly told about the problems of our planning and others. Now, as it's not only the British engineers, the Damodar Valley Corporation, as we learned in the school that it was built on the basis of this Tennessee Valley Authority, TVA. TVA, and when we were in school in mid-70s or others, this was something remarkable, that we have planned a river valley basin on the basis of something borrowed from US. But as Professor Rudra has already told that we did not understand the nature of our tropical rivers. As I was saying, that whenever I go outside and see the beautiful rivers with clean water and others and different types of river sports, tourism, most of the big cities of the world have a river cruise along that. That is in London, that is in Rhine and everywhere. That is insane. Whenever you look at it, and we see that they are exploiting the river. They're exploiting the river commercially. But at the same time, they're maintaining the river. They're maintaining the river, which we cannot. Now, one of my geographer friends, when I asked about this, he said that this is because of the nature of the tropical rivers, that is because of the sediment is carried, that we cannot have that type of blue transparent water in our tropical rivers. I don't know, I'm not a geographer, and whatever I do as an economist, I try to put it into a supply-demand framework. That what is the demand for this river, and what are the demands for this river, as I have said, that it is the source of all the resources, but we also use it as a sink, and when proportionately the use of sink increases compared to the our thinking about it's the source of everything, we try to throw anything and everything in the river. And the day before yesterday, Professor Rudra told us that we worship the river, but we forget it after that. After that, that is the thing. If you go to any of the ghats in our in Kolkata, Babu Ghat or anything, you will see that our religion is so much connected with the river. That is our last rites and etc. are done with the river. And then what do? We throw everything in the river. We just when there are strict vigilance and controls just after the big pujas and others, I find that people do not throw; they keep it on the designated bins and others. But otherwise, people just throw it; they don't care. They just don't care. I have seen that whenever you go in the festival season, in Durga Puja, in Lokhi Puja, coming to the Kali Puja thing, there are strict vigilance. But if you go to the Ganges for the same thing, for the immersion during the Saraswati Puja, you will see there will be no control. Absolutely no control. Everybody is doing anything. Now, of course, human activity causes stress to everything. Stress to everything, even when the boatman goes through the river, his oar is into there, and that is also causing vibration. But once upon a time, when we are not so commercially inclined and others, the boatman knew the river. The boatman knew the river. If you go through, our Bengal is called Nodi Matrik, that is, river is a mother. And if you go through the gems of so-called Bengali literature, either Padma Nodin Majhi or Tita Shekti Nodin Nam or even Ganga, you will see that the fishermen, they could smell the water. They could smell the water and they could find out that whether the shoals of fish are coming or not. But what our development process, especially in the post-independence period, we forgot this type of knowledges and this type of indigenous things. Now we are talking about stakeholders and others, but in our development process, somehow we just subtracted these people from this stakeholder thing and every other thing. So that we, with commercial, with industries and others, I still remember when I was a child, I was with my family, I went to Dakshineshwar, and when we went to the ghat, we found the water red. And somebody told me that is for the waste coming from the nearby Wimco, the matches factory. Of course, there were the days when these pollution control acts were not there, and these were not there. These were way back in 72, 73. And my mother said me, don't touch the water. Just don't touch the water. Then when the pollution control boards, the Central Pollution Control Board and the State Pollution Control Boards were formed in the early 70s, and this pollution checking for the industries became mandatory. We got to know about these terms, BOD, COD, dissolved oxygen, and all those things. But whatever these terms have came, there were pollution control laboratories to check pollution of the industries and others. But somehow that gave a U-turn. Now, you can say, of course, there are factories along the river, but the number is much small compared to what was there even in the 1960s and others. And you will hear a complaint that because of the restrictions of pollution, we have to close down. So there arises a conflict between the livelihood of the people who depend on these factories and the livelihood of the people who depend on the natural resource, that is the river. And that takes us to the point of the management of the river. That what do we mean by management? What do we mean by management? Now, urbanization, as I was saying, that I have worked with urban issues all over my life. And now, whenever I see that this urbanization and the industrialization, etc., everything is blamed for that. But what is happening, as Professor Rudra has already told, that when the river flooded, it took the sediment and that was beneficial for agriculture. But if now that happens, we blame it on the river, we blame it on the drainage system because we don't need the sediment. The urbanites, the urban citizen, they don't need the sediments. They don't need the sediments, so if the city gets waterlogged because of a bad functioning drainage system or a heavy rain which is out of the capacity of the so-called pumping stations, we blame it on nature. We blame it on nature, and I just reminded of Syed Mustafa Ali's line that rain, why it is needed in the cities. So he was writing about what suddenly he was in Egypt and suddenly one day the rain came and the people were very angry because they haven't seen rain, and they said, he said, I tried to talk about that agriculture and others. He said, for agriculture it is needed, then let it be in the villages. Let it be in the villages. What's the need of it in the urban areas? So it's a disconnect with the urban areas from the natural resources, from the other things. Every year I take my students of urban economics specialization to the Polta waterworks. And that is the first time they could get the idea that how the potable water is present. I still remember one of my students, he said, whenever I open the tap in my house, I get the water. And when I don't get it, I blame it on everybody. But this is the first time I could see that how water is being produced for drinking and other purposes. Afterwards, I will never waste a drop of water. So this is, I think that is one of my achievements, that I could at least tell them that this is the way we are using resources, but we are not giving anything back to them. So I was looking about the stakeholders thing. Now I went to these some of the websites of central government and others. Yesterday, the people from NMCG and NIUA, they talked of various things like Ganga Mitro, Ganga Prohori. Fortunately or unfortunately, I haven't seen them in West Bengal or heard them about them in West Bengal, that how they are being involved and others. But the point is that is this awareness. This awareness doesn't stop with just creating a procession, Nodi Bachao and all that. That will not do. We have to understand that the rivers, or for that matter, any other water body, is a resource, and we have to preserve that resource for our own survival. As I was saying, as Professor Rudra has said, that the Damodar Valley Corporation and others, what that has done, that Damodar used to change its course. That's why the British used to call it Bangla Dukho or something like that. But it created the Oxbow lakes throughout this channel. Now we will find all those Oxbow lakes are almost dead. And the rivers from the western side of Bengal, Ojoy, Moyurakhi, Rupnarayan, etc., they used to give a very good amount of water to the river Hooghly in the rainy season, which washed away the pollutions and others. Now we are blaming pollution, we are blaming things, but there is a natural cleaning process which we have already changed. But the point is that whatever we say, we cannot reverse the so-called wheel of civilization. We can blame it. We can blame it on the commercial thing. We can blame it on interrupting with the natural cycles of different types and so and so. But again, we cannot, quoting from Rabindranath, Dao phire se aranyo, we can never go back to that age, Dao phire se aranyo. Even if we go for ecotourism, we would want that our mobile would have the proper signal and we would have all the modern amenities in those eco-resorts. So that is something which cannot be done. But what is the way out? What is the way out? And in that, I would like to talk about taking a holistic view of each and every water body. It's not that only one Ganga rejuvenation thing or something other, etc. The rivers are to be thought as the part of the whole system, each and every river. Each and every river, so if anything happens in the upper bound, that is definitely affect the lower bound of the river, and this goes on. And if you look into, and of course there are political boundaries between the countries, political boundaries between the states, and different types of so-called interest groups and others are there. We are just hearing about in the morning about something waterland in Ramsar site in Maharashtra, how it is being destroyed with dams and others. So I think that this is tough, but this will not happen if we cannot take a holistic view of the river system as a whole, and also all the connecting water bodies. We talk about Tribeni. You can still find fringes of this river Saraswati, but we have lost Jamuna. That is being transformed into a canal, and that is called Bagher Khal. So we have transformed the river into a khal. We have transformed the Adi Ganga into the Talis Nala, and Talis Nala is one of the most polluted stretches of the river. Everybody knows that. So it's the consciousness, awareness on the part of each and every stakeholder. It's the duty of the so-called authorities, the so-called the river action, it is dealing with rivers, and also the urban local bodies, even the rural local bodies, the panchayat, etc. They have to be involved in this holistic plan and raising awareness. Otherwise, as we are seeing, that fishes are dwindling. মাছে ভাতে বাঙালি, মাছের এখন যা দাম যেখানে গিয়ে পৌঁছেছে, আমরা বাচ্চাদের বলি যে they don't eat anything but chicken, but are we being able to give them the variety which even we had in our childhood? So we have to look into it. Whenever there is a project or something, there is a mandatory EIA, environmental impact assessment, and I was involved in one of such environmental impact assessment when an additional jetty was being built in Holdia port. And when there was talk about that, what would happen if pillars are being made with what would happen to the fish population and others, and also the aquatic plants and this. Then one of my team members, he said, don't worry about that. Natural resources have a capacity to rejuvenate themselves. That is another problem, that we ignore what we are doing. We are thinking that nature is overpowerful, and that is a problem. So we have to accept that there would be commercial exploitation. There would be then one way would be to go for more and more green production systems, which would have less waste, which would pour less waste in the rivers. And of course creating awareness. So thank you, and again thanks for the organizers for giving me a chance to talk.
Thank you everybody, thank you all the panelists for the wonderful panel discussion. I now request all the panelists to take their seats on the audience. Okay, so now that we are going for the valedictory session, at first we have welcome note by Ms. Bulu Boshak, Faculty, Geoinformatics Division, South Asian Institute for Advanced Research and Development. Welcome, Ms. Bulu Boshak.
It is our great honor and pleasure to welcome everyone in this first International River Congress. With due respect, I would like to welcome all the eminent speakers and guests of this program. I also want to thank who have presented their papers in this program. Thank you, everyone. And now for continuing valedictory session, I would like to hand over the microphone to Antara Kundu ma'am. Thank you, everyone.
Okay, so now I would like to invite all the delegates on the dais. As we have already on stage Dr. Kalyan Rudra. I'd like to request Dr. Tapati Banerjee, Director NATMO, to come up on the stage. Honorable guest, Dr. S. Shamanto, HOD, River Ecology and Fisheries Division, ICAR, Central Inland Fisheries Institute, Barakpur, West Bengal. Dr. M. Shashi Kumar, Joint Director, Anthropological Survey of India. And Dr. Bishwajit Roy Chaudhuri, Chairperson, Saiard, to come up on stage and take the seats. And we also have our chief guest, G. Ashok Kumar, IAS, Additional Secretary and Mission Director, National Water Mission, Ministry of Jal Shakti, Government of India. He has been joining us through online. I request our team member to connect him. And now, for felicitation, I would like to call upon stage Mr. Piyush Gupta, Real-Time Information Specialist, National Mission for Clean Ganga, Ministry of Jal Shakti, Government of India, so that we can give the felicitation to G. Ashok Kumar, and I request Dr. Piyush Gupta to receive the award on behalf of him. I request our team members to bring the mementos on stage. And can I request Dr. Bishwajit Roy Chaudhuri to give the felicitation mementos to Piyush Gupta, sir? And I'd also like Mr. Piyush Gupta to receive the felicitation of Honorable Director Sir, Mr. Rajiv Ranjan Mishra, Director NMCG. I request our team members. I request our team members to bring the mementos on stage. This felicitation goes to Mr. Rajiv Ranjan Mishra, and on behalf of him, I'd like Mr. Piyush Gupta to receive it. Okay, so thank you everybody. Now, I'd like to invite Dr. Bishwajit Roy Chaudhuri, the founder chairperson, Saiard and IIGST, to sum this session. Okay, pardon me. I'd like to request Dr. Bishwajit Roy Chaudhuri to felicitate Dr. Tapati Banerjee, Director, National Atlas Thematic Mapping Organization. I kindly request Dr. Roy Chaudhuri to felicitate S. Shamanto, Dr. S. Shamanto, HOD, River Ecology and Fisheries Division, ICAR, Central Inland Fisheries Institute, Barakpur, West Bengal. I request Dr. Bishwit Rai Chaudhuri to felicitate Dr. Kalyan Rudro, Chairman, West Bengal Pollution Control Board, Government of West Bengal. And I request Dr. Bishwit Rai Chaudhuri to felicitate Dr. M. Shashi Kumar, Joint Director, Anthropological Survey of India. I request our team members to bring the mementos on stage. And now I am going to request Dr. Bishwit Rai Chaudhuri, the founder, chairperson, Saiard and IIGST, to say a few words. Over to you, sir.
Thank you, Antara. Finally, the wait is over. And right now we are in the moment of valedictory session of our first International Rever Congress, which is organized by our institution along with some our strategic sponsors and knowledge partners. These 3 days, we are really enriched by the honorable lectures of some eminent dignitaries, and especially I would like to give my sincere thanks to the Honorable Director General of NMCG, Sri Rajiv Ranjan Misra sir, Honorable Director Sri Hitesh Vaidya of National Institute of Urban Affairs and his team. Another, I would like to convey my sincere thanks to the West Bengal Pollution Control Board Chairman, Dr. Kalyan Rudro, though he is one kind of Dronacharya for me, and all the delegates, all the participants from the different government bodies like CFRI, NATMO, Dr. Tapti Banerjee, for their heartfelt support to make this event a grand success. On this note, I would like to share some points to all of you. That Saiard, whenever it has started its journey, from the very beginning of our institution, we are focusing from the community-based activities to include our activities, include the vision of the government in front of the into the mind of the people. Because government, so-called, whatever we feel about the government officials, that they are just sitting there on their chair, they are just enjoying some luxuries. It's not. Because whatever the experience I have gained from throughout my work, I feel that whatever the pressures they have to take in, and we as an Saiard-like institutions have a responsibility also, I feel, that we have to take some responsibilities. We can share our hands with them, not only for in a mindset that we will bring money from them, how we can get some opportunities from them, not as an opportunist, but also as a friend, as a collaborator, as an R&D lab. And that's why from the very beginning of our institution, we have started our journey in association with the NATMO. And I thankful to Dr. Tapti Banerjee and the honorable officials of DST Government of India for sharing their sincere supports with us And our first MOU was done with the NATMO. And we are happy that through this activity, through the collaboration of NATMO, we have already engaged several peoples as an employee. We can also provide some employment, we can create some employment opportunities for our students. And here, both the NATMO, NIU and NMCG representatives are there. Recently, we have signed MOU. Whenever I discuss, after signing this MOU, I have proposed that if there will be water summit, why not there will be a river congress? And every members of the board agreed with me and tell yes, where the water will come, where from the water, what is the source of water, why not we should focus on that. And you are right, you may proceed, we are here. And for that, on behalf of Saiard, I give a big thanks to both of the organizations. Along with that, whenever I went to with this approach to our Honorable State Minister, I would like to share my sincere thanks to the Honorable Minister of Environment, Government of West Bengal, Dr. Ratna De Nag. She heard about the concept, she heard about the thinkings of Saiard, and she appreciated, mostly though she told that hopefully I will not be able to join due to some assembly activities there, but I shall definitely try, I will definitely try to join at 90%, 98% I shall try to join. But she already promised that she will also thinking for some collaborative approach. Not only that, I have already reached to the Principal Secretary, Honorable Principal Secretary of Ministry of Irrigation and Waterways. I have reached to my sincere sir, my Dronacharya, Dr. Kallan Rudro. I proposed my thinkings that, sir, I would like to do that. And you are the masterpiece in that field. So without your presence, without your gracious presence, it is not possible for me to formulate this whole infrastructure, this type of conference. And I am thankful from this podium. I share my sincere thanks to that man that within just a phone call, he agreed that yes, Bishwajit, you may proceed, I will go with you. And within his busy schedule, 2 days from in the first our inaugural session, and today is the valedictory session, he is sitting with us, and I hope you may understand what is the zeal about a person, about a river a man have, for that he is here. And I am thankful, sir, once again on behalf of Saiard. I would like to share my sincere thanks to the Ministry of Ayush, the representatives, those who have, sir, Dr. T.K. Mandal, sir, Director, sir, will not be able to join, he regrets, but unfortunately, he will not be able to join, but he sent his representative. I would like to share my sincere thanks to Kaushik, sir, from the Assistant Professor of Netaji Subhash Administrative Training Institute. My sincere thanks to one of my indirect madam, another Dronacharya, Dr. Mahalaya Chatterjee, and also all the dignitaries, those who are present here within these 3 days, and especially my friend of NMCG, Mr. Piyush Gupta, my colleagues right now, we are saying that NMCG and NIU and Saiard is a family, and right now we are working in a collaborative projects in an Assam sector and Assam district and in West Bengal, and Rahul Sachdeva sir, Uday Bhonde sir, Vishakha ma'am, Nandini, all are now associated, so we are the family, and only we are focusing how to develop a livelihood sector. Do not think river just as a resource, as I said yesterday in my previous lecture. Don't think it as a resource, just think it's a source, and how this source feeds us, and how this source helps to sustain our life, our society, our economy, our everything. So that is the main thinking of this River Congress, and that's why we have used the catchline, Think River Differently. And from this podium, I would like to express that this River Congress is already become so much popular. Doordarshan channel, Anandabazar Patrika, even BBC International will cover the whole River Congress event. Along with that, we also got some proposal from the country of Australia, Belgium, Bangladesh, and today in from Sri Lanka, they want to host this event in coming year also. And really, the activities which we have done for doing this successful, it's hopefully you can understand from my face. And for that, I would not but least, I would like to share my sincere thanks to all my team members, and I will request please give a big hands applause for them, and I will request to them please come on the stage also to stand by in the front. Without their support, I can't do that. And also my fighter, my criticism, my criticizer, my wife, Srimati Dr. Aparna Bera Roy Chaudhary. Without her support, it's not possible for me. She is also the vice chairperson of Saiard, and most of the time we are working like just not a friend but a colleague rather than a husband-wife. So thank you once again to all of you for supporting us. And before I concluding my speech, I will also share my sincere thanks to the Honorable Director of Anthropological Survey of India, Dr. Gauri Basu, and also Dr. Shashi Kumar Sir is there, Joint Director of Anthropological Survey of India, and his officials, and all the supporting members from sweeper to the lightman to auditorium, and all the teams, those who have joined from the event management sector, refreshment sectors. So on behalf of Saiard, it's a big thanks to all of you. Thank you so much.
Thank you so much, Dr. Bishwajit Roy Chaudhary. Now, I would like to request Dr. Tapati Banerjee, Director, National Atlas and Thematic Mapping Organization, Government of India, to say a few words. Over to you, ma'am.
Thank you, Antara. First of all, if I start saying something, I think few words are too few to say. So first of all, I congratulate Bishwajit Roy Chaudhary and his wife and all the young members, especially his team he is working with his young team, young group members for such a nice Congress. I should say the first River Congress, his concept, his idea, really, I'm overwhelmed. Really, he is the only person who could be able to assimilate all the experts, right from rivers, all the stakeholders, geomorphologists, river geomorphologists, geographers, with the holistic approach, he could be able to bring together higher officials, even the judges, and the researchers, technologists from different universities in the one single platform in the name of first International River Congress. Really, it is overwhelming. I think everybody should appreciate him. But still, I should say that there is still incompletion is there. That is not complete. He should arrange one visit on that river tourism, what we say, then we could find out the real scenario, what we speak here, what we show here, how it is differing with the real-time scenario. Really, we have to think on that. We have listened about that river, history of river. As we all know that in the very beginning of our civilization, that concept, every civilization started with that river basin or river bank, with the concept of citadel, that the highest part where the grains were used to accumulate by the people of that time, then that area's household, then the bank.
But that concept, all concept has gone. Now we are facing several problems because I should speak in Bengali, my own language, that is গোড়ায় গলদ। আমরা সত্যি সেই জায়গায় পৌঁছেছি, we have reached to that area, গোড়ায় গলদ। Just in that last session, Dr. Srikanto, who is my colleague of my earlier institute, he showed that how the plastics, they are accumulating instead of fish. What is the source of these plastics? We should think on that. And we have listened so many of research papers and that how that sources, how the information we are getting through direct information or that indirect information through remote sensing, other devices we are using to collect information. We are working on that research, but how far it is reaching to the community. As the Fisheries department, they are working for the communities. Recently, we had a meeting with the NGOs, and the NGOs, they are working so nicely. They have given one information that they are working every day. They are taking that information, data, they are collecting from the coastal rivers, Matla and other rivers, and they are saying that in that rise of that water level, in the low tide as well as in the high tide. So we should work with the community people. We should develop our awareness. How? I believe we are not aware. We are not at all aware of the use of the not only river, the river water resources. If I ask you, you please raise your hand who are having the RO in your home. You are using in your home. Most of people, they are using RO. How much water got lost out of this RO system? Nobody knows. Where hardly people know. So what is the... Then this is the some part, I should say, but now there is scope to do this. Madam just, she informed about that some of the rivers we are now call them as the Nala. And being a resident of North Chobbish Pargana, I just want to mention the name of 3 rivers. Now they have totally disappeared or converted to canal. One is the Lavanyabati, second one is that Subarnabati, third one is that Ganga. Lavanyabati, that is now known as Noai Canal. And these 3 rivers were very famous for trade purposes. And Subarnabati, Shuti river disappeared. Ganga, you won't find any river over there. That time, once upon a time, the Padda that was flowing, and that development of that Janpad, we used to say, Ganga, that has developed, now that river disappeared. Then what will be our future? There are so many instances, they are in that Hooghly area, below that, that lower part of the Ganga basin. So I think everybody is busy, there's a time shortage. So we should again and again think on that. We should be aware first, then we should develop our awareness. I think some of the colleges, they are doing very good work by cleaning project. Everybody should be involved. And Dr. Piyush, he was informing that several stations, monitoring stations they have developed. How far it is working, nobody knows. So that type of low-cost technology should be used to get the information at different levels. So I don't want to discuss anymore because there'll be a long discussion. So with this, I again convey my sincere thanks to all of you, especially to Dr. Vishwajit for inviting me here. I, being a director of NATMO, I can assure you that if anyone wants any help from NATMO on that use of this geospatial technology or any other kind of help, I am ready to help to all of you. With this, I thank you again. Thank you all.
Thank you, Dr. Tapati Banerjee. Now, I'd like to request our chief guest, G. Ashok Kumar, IAS, Additional Secretary and Mission Director, Okay. So, am I audible, sir?
Yes, yes.
Okay. So I'd like to request you to give your address, sir. You are our chief guest. You are IAS Additional Secretary and Mission Director, National Water Mission, Ministry of Jal Shakti and Government of India. Thank you for joining us, sir. And over to you, sir.
Am I audible?
Yes, sir. You are audible, sir.
Okay. Thanks for giving us opportunity. Sorry that I had to rush through because we have a meeting coming up.
Am I audible, sir?
Yes, yes, audible. Yes.
Okay. So I'd like to request you to give your address, sir. You are our chief guest. You are IAS Additional Secretary and Mission Director, National Water Mission, Ministry of Jal Shakti and Government of India. Thank you for joining us, sir. And over to you, sir.
So, good afternoon, everybody. Good afternoon, everybody.
Good afternoon, sir.
Am I audible?
Yes, sir. You are audible, sir.
Okay. Assuming that I'm audible, I'm just going ahead. Thanks, Mrs. Roy Chaudhary, Doctor, for organizing this conference. This is the first river conference, an international river conference. And this is a very, very important subject because suddenly I find that the water and the river, which is a conduct of the river, the water has become very, very important. Most of the speakers before me had actually spoke about the connect of river with human evolution, civilization, and progress as well. And as a country, we used to respect rivers, invoking them in our prayers every day. But somehow over the years, maybe a couple of centuries, we have sort of lost the connect with the river because we had lost the respect for rivers and started treating water river as a sink for all the pollution which we can putting the pollution onto the river, and also taking away the water for irrigation purposes. So we find many streams have dried up, and these dried up stream areas have been encroached upon and totally killing the rivers and the rivulets. So it's high time that we get back the respect for water, get back the respect for a river, and try to revive the ecology. Particularly very important because of the various issues we see now with the climate change. The rainfall pattern has changed. The global warming is happening up. So all these things require probably a better connect with all of us with the river and water, and that's where the government of India has realized the importance of conserving water, and the Honorable Prime Minister in his the last term from 2019 when he came back, he has integrated all the various departments dealing with water and formed a Jal Shakti Mantralaya to have a coordinate approach on the water issues. So that has really helped in creating a unified command and control, and also for taking a better informed decision. So the Namami Ganga, which we all been mentioning about earlier, had been doing a wonderful job. I was also part of it as ED projects earlier, and probably from January 1st we'll be taking over as Director General of the Namami Ganga project. So it has done a wonderful job in making awareness of the importance of river, and also cleaning up the river water to very, very high standard. We have seen the encomium coming from the Prime Minister and the very other people who had been took the bath in the river, and the Kumbh, thousands of people which visited the Prayagraj during the Kumbh. They all have been mentioning and praising the efforts of the National Mission for Clean Ganga. Lot more has to be done. We will be involving people as mentioned earlier, using Ganga Praharis, and the people staying around the river will be made a part of the conservation program, and definitely this the lessons learned in the successful rejuvenation and conservation of Ganga and cleaning of Ganga would be taken up for the similar process in other rivers of the country. Now, the biodiversity has increased in many places. There was a presentation earlier I saw from the CIFRI. The biodiversity has increased. There are many of them, the species which we thought extinct has come back, and the river has become much more organic and living. So before concluding, I would like to say 3 or 4 major points I would like to say here as far as river is concerned. One is the quantity of water which flows in the river. That's very important because over the years we had been either drawing a lot of water from this river for drinking water purposes or for irrigation to a large extent. So this has really reduced the flow of water in the river to a trickle many places, and also this has led to the encroachment of river, and this positive cycle reducing the flow of water and then encroachment, and further reduce the flow of water in the river. Further encroachment has resulted in many rivulets and rivers disappearing. So the trust now is to ensure that minimum environmental flow is maintained in the rivers. River Ganga has notified the first time the minimum ecological flow or environmental flow in the river. So this would be a process which will be tying up in other rivers also. The second, for this, Government of India had started the Catch the Rain campaign, a very successful campaign launched by the Honorable Prime Minister himself to catch the rain where it falls, when it falls. And I'm very happy to tell you that in the last 6-7 months of the campaign, which started on March 22nd by the Honorable Prime Minister himself, we have actually done more than 45 lakh structures of rainwater harvesting structures in the country. And with the copious rain which we received, definitely a lot of water has been conserved. And we hope to see that the water table in the country would have definitely gone up in many of the places. And also the flow of river will also will be increasing because of the slow release from the wetlands and the small rivulets which we have rejuvenated under this campaign. The second important aspect is about the quality, deteriorating water quality. People have mentioned about it. The urban, particularly the main blame is taken by the urban bodies, but National Water Mission and as well as the National Mission for Clean Ganga have been working with that. So urban river management plan has been sort of tried out. Alliance of cities, the alliance of rivers and cities has been formed so far. 30 cities have joined the River City Alliance. So this also would go a long way in probably looking at the quality aspects of the water, which is mostly polluted by the sewage coming out from the municipalities. So urban planning and river will be an integrated part of the urban planning, and we continue to do with that. And the third and very important aspect is about the data. We have to get correct and good data to make informed decisions. So this is one of the major lacuna we find in the country. So data management and collecting correct data on real-time basis, and also getting standard data all of the country is one of the major challenge which we are facing and which we are also going to address. So river basin governance and the role of the state government and central government is very crucial. There is a lot of issues between the state government and the central government, and between the state governments on this water governance issues. But hopefully things would be getting sorted out. The Ken Betwa project, which has been approved by the cabinet recently, is probably the first interlinking project which has been coming up in our country. So there is a movement towards better federal governance in river basin management. So I hope that this will lead to better conservation of rivers, better rejuvenation of rivers, and the conferences like this which you have held here would be giving a platform for many people to share their views and ideas. And I've seen some of the beautiful presentations which you have done here. So this this is actually a good beginning for discussion and deliberations and action on river conservation. I thank once again Dr. Bishwajit Roy Chaudhary for and his team for organizing this conference, and hope that as mentioned by him, this would be a regular process, and also get more and more people associated from various parts of the country and various parts of the world for the conservation of river all over. Thanks again.
Thank you so much, sir. Sir, am I audible?
Yes, please go ahead.
Thank you so much for giving your valuable time within your busy schedule, and hope this conference in your second International River Congress, you will be with us. We hope so. And for that, I would like to give my sincere thanks to all the, on behalf of all Saiard team and all the audience. And very soon we will meet, sir. Thank you so much. And please give a big hands for him.
Thank you.
Okay, so thank you so much, sir. Now I'd like to request Dr. Kalyan Rudra, Chairman, West Bengal Pollution Control Board, Government of West Bengal, to say a few words. Over to you, sir.
I'm coming back to this podium for the third time. Last 3 days, we had been discussing rivers.
Kalyan Rudra, Chairman, West Bengal Pollution.
For last 3 days, we are now at the end. My simple question is, what is the take-home message, Vishwajit? Let me conclude in one sentence. My dear friend, my students, please don't consider river as a stock. It is a flow. This is the most important message I like to take it home. Don't consider the river as the conduit of most convenient outlet of the wastewater and solid, which had been we are doing for the since the colonial period. One important, I always request my dear student, please don't accept single-use plastic. Can we all take an oath here that we shall not use single-use plastic from tomorrow? How many of you agreed with this proposal? Please raise your hand. This will change our ecosystem largely. Lastly, Saiard has many young representatives. Can we go to the ghats, any one ghats of the Ganga once in a month and make it clean? This may be a regular program of the Saiard. That will be the participation. Otherwise, these 3 days exercise will be a futile exercise. Please allow me to refer one song, at least few lines of that song. It was by my good friend Kabir Suman. He said, "Ami gan gailam, কিছুই তেমন হলো না, যা কি ছিল আগের মতো রয়ে গেল." I don't want everything to আগের মতো রয়ে যাওয়া. Let us try for a change. It will be achieved, I am sure. Thank you all for your patient hearing. Lastly, Vishwajit, one more issue. Pollution Control Board is a custodian of a huge database. We monitor the water quality of the Ganga every month, starting from Farakka down to Ganga Sagar. It is always available in public domain. We have a website, wbpcb.gov.in. Any student, any researcher, if like to access, please, you may visit our website. And we are also expanding our air quality monitoring network. This is going to be the largest and most intensive network of the country. That is also publicly available, not only through our website, but we have a website which we can clearly download, what we call Poribesh app, from the Google Play stores, and it is accessible by any students, any researcher, any citizen of the India. Thank you.
Thank you so much, Dr. Kalyan Rudra. Now I'd like to request Dr. S. Shamanto, HOD, River Ecology and Fisheries Division, ICA, Central Inland Fisheries Institute, Barrackpur, West Bengal, to say a few words. Over to you, sir.
Thank you very much. From CIFRI side, I would like to thank everyone present here and also in the online mode. Basically, the thinking is that we should think about the community, not a particular person or particular biotic organism. In totality, we should think of, when we think of river, it is basically a living system. What our ancient persons used to tell, Mother, Ma Ganga, or like that. Every river is like mother and it sustains all the living organisms. That should we keep in mind. We should grow ourselves for the sustenance of the nature, and we should think of every organism, be it small, be it large. Everyone has the power to survive in the system, grow and live happily. Thank you. Thank you all.
And now, finally, I'd like to request Dr. M. Shashikumar, Joint Director, Anthropological Survey of India, to say a few words. Over to you, sir.
Respected dignitaries on the dais and dear delegates of the seminar, I really congratulate Dr. Roy Chaudhary for organizing the first ever International River Conference. And I thank him for giving us an opportunity to collaborate with him in a small way. So this is a very, very important topic which we have to be discussed, and not only to be discussed and to be practiced. So when I was a student at the school level, I remember my social science teacher telling me, dear students, if at all there will be a third world war, that war will be for the sharing of water. So I don't know how much it is true, but the message he wanted to give to his students was very clear. And we being the anthropologists, and you are from the other side, I don't know what the role the anthropologists have in this respect. But I think for the many years, we have developed or we have inculcated a culture in which the earlier speaker was talking about our cultural practices, some of our religious practices are also playing the role in polluting the water. But what I suggest is that there should be a reversal of that. We have to inculcate a culture in our in our coming generation, that how to keep clean the sources of our the river sources of our country. So there are some certain models, though it is in a smaller way in the different parts of the country, from which we had to learn some certain lessons, or we had to try to at least practice it in not in a big way, but in a smaller way. Last week I was in Shillong. I visited the village called Maulinong. I was visiting that village after 20 years. In 2002, I visited that area. Maulinong is said to be the cleanest village in the country. It is in the East Khasi Hills district of Meghalaya. And through that village, that famous Umnong River is passing. That Umnong River is also said to be the cleanest river in Asia. And it will flow to the Dauki area, then it will join to the Bangladesh. That is the thing. So the cleanest, they developed a model in the year 2002. The villagers has taken a decision that the village has to be kept clean, and the water should be kept clean, and everything should be in clean. If some of you might have gone there, the villages say you will really feel that you have been in a garden. You cannot see anything, any wastage at any part of the village. And if last 20 years it has improved a lot. Someone was talking about the river tourism. Of course, tourism has developed a lot there, but the cleanliness of the village, the cleanliness of the water of the Umnong River, it has enhanced several fold. So we were doing some boating in that river, and I take some water in my mouth just to taste it. Then I could not spit it back. My conscience didn't allow me to spit it back to the river. Then I just drank it. So that is because the atmosphere tells us that this is the way we have to behave in such a situation. Because here we are more and more people are polluting our rivers. There it is quite on the rivers. So that is why I'm telling we have to inculcate a culture which will help us to clean more and more of our rivers, and in that process, in India, because of its specific geographical setting, there is no dearth of water, but a lot of people among us are not getting enough drinking water. This is the tragedy. So I hope this International River Conference will lead the society to think forward in this respect. Thank you very much.
Thank you so much, sir. So now we are going for a small award ceremony. Our first category is Best Exhibitor Award, and the first one to receive it is National Mission for Clean Ganga. I'd like to request the representative to come up on stage, and I would like to request Dr. Bishwajit Roy Chaudhary to present the award. I request our team members to bring the award for National Mission for Clean Ganga. Okay, the next award goes to National Atlas Thematic Mapping Organization. I'd like to request the representative to receive it, and I request Dr. Bishwajit Roy Chaudhary to present the award. Okay, so the award is received by Director NATMO, Dr. Tapati Banerjee. And I think we have
Director NATMO, she does whatever she achieves. That is the work of the team members. So I request Bishwajit to hand it over the award to our team members.
The next exhibitor award goes to Comunidad. I request the representative to come up on stage and collect the award. Thank you so much, sir. Thank you, Comunidad. Okay, the next category of award is Best Paper Presenters, and the award goes to Professor Dr. Kumkum Bhattacharya, Dr. Shubha Lakshmi Gupta, and Dr. Abirlal Sanyal. I request all of you to come up on stage and receive the award. I request Dr. Bishwajit Roy Chaudhary to present the award. Thank you so much, sir. Thank you so much, ma'am. As we nearly come to the end of the session, I'd like to request Mr. Arindam Ray, Director, Academic Affairs, Saiard, to present the vote of thanks. Over to you, sir.
Good afternoon, everyone. I, Arindam Ray, on behalf of Saiard and the entire fraternity of the institution, first of all, extend my most sincere thanks to the Almighty God for making the 3-day program a resounding success. We have now arrived at the end of the 3-day program of International River Congress organized by South Asian Institute for Advanced Research and Development. First, I would like to thank Mr. Rajiv Ranjan Mishra, the Director General of NMCG, Mr. Hitesh Vaidya, Director NIUA, Sri Shoibal Dasgupta, Honorable Expert Member, National Green Tribunal, Eastern Zone Bench, Kolkata, Honorable Justice B.S. Tralikar, Judicial Member, National Green Tribunal, Eastern Zone Bench, Kolkata, Mr. Nakamura Yutaka, Honorable Consulate General of Japan in Kolkata, Dr. Gauri Basu, Director, Anthropological Survey of India, Dr. Kullan Rudro, the Chairman, West Bengal Pollution Control Board, Government of West Bengal, and I would like to special thank G. Ashok Kumar, IAS Additional Secretary and Mission Director, National Water Mission, Ministry of Jal Shakti, Government of India. Sir, your thoughts have enlightened our minds and have shown us a new path. I am immensely thankful to the entire team of NMCG and NIWA for their wonderful roundtable conference over river and cities, the River People Connect, and I need to mention my deepest sense of appreciation to the entire team of CEPT University, GIZ India, IIT Kharagpur for their wonderful national roundtable discussion on the inclusive and resilient approach, the water-sensitive urban development in India. I also extend thanks to NATMO, Government of India, NESAC, IIRS, State Water Investigation Department, Government of West Bengal, India Meteorological Department, Government of India, Uttarakhand State Disaster Management Authority, Government of Uttarakhand, University of Dhaka, International Water Management Institute, Colombo, Sri Lanka, for their continuous support throughout the 3 days in different technical sessions. My gratitude to all the special lecturers and all the paper presenters who are present physically and virtually from every corner of the world for gracing the occasion and sharing their opinions. I would also like to thank Sripad Singh College, Atal Bihari Vajpayee Vishwavidyalaya, Sri Shikshayatan College, Chaitra Ramay Pandit Mahavidyalaya, Medicaps University, Vivekananda Mission Mahavidyalaya for their propagation of Save River campaign, and I wish they continue their hard work. I extend a hearty vote of thanks to Dr. Mohua Mukherjee and team and Sri Shuddhasattva Bhattacharya and team for their splendid cultural events. Besides this, I want to give a special thank to Anthropological Survey of India for their tremendous support by giving us this platform and technical assistance. I want to thank the Shayandeep Roy and his assistants for the coverage of event through the photography and the Gajapati Caterer for Fooding Department. Last but not the least, a big thank you to the entire team of Saiard who made this International River Congress memorable for all of us. I hope that your support will be there with Saiard in upcoming events also. So we conclude the program here. Thank you very much. And now I request everyone to stand up for our national anthem. Thank you. Jai Hind. Thank you, everyone. Over to you, Antara.
So, With that, ladies and gentlemen, we have come to the end of our 3 days grand celebration named as International River Congress. We are honored and much privileged with your glorious presence, and we hope that you have enjoyed every session. So, one last time from the entire organizing committee of South Asian Institute for Advanced Research and Development, we thank you for being a part of Saiard family for 3 days and hope you had as much fun as we had putting this together. This is Antara signing off. We are going to see you very soon. Thank you, ladies and gentlemen. Goodbye and stay safe. Thank you, everybody.